What if the universe holds hidden terrors that can swallow entire stars? Black holes. The silent giants of space challenge our understanding of reality. This journey delves into the depths of the cosmos, revealing shadowy creatures like the mind-boggling titan known as Ton 618, a void of unimaginable mass. We'll confront the mysteries surrounding the ominous black hole in OJ 287, the heart of our own Milky Way, a lurking beast called Sagittarius A star, and the relentless consume of energy by M87 star. Join us as we delve into the most horrifying black holes in the universe. Ton 618 stands out as one of the largest black holes we know of, and its frightening characteristics are rooted in both its massive size and its insatiable appetite. Imagine something millions of times heavier than our Sun packed into an infinitely small point. That's what Ton 618 represents, a black hole with a mass that exceeds 66 billion suns. This immense gravity creates a powerful pull that draws in everything nearby, including gas, dust, and even entire stars. What makes Ton 618 even more terrifying is not just its size, but its activity. As matter spirals into the black hole, it heats up and emits intense radiation, making it visible from far across the universe. This radiant energy can outshine entire galaxies, marking Ton 618 as a quasar, a bright beacon that signals intense destruction in its vicinity. Its abilities to consume and radiate signify the dramatic effects a black hole can have on everything around it, turning it into a cosmic vacuum that transforms space. Moreover, its distance from Earth, at billions of light-years away, reminds us of the vastness of the universe and how many more similar behemoths may exist. Studying Ton 618 helps scientists understand the formation and evolution of black holes, as well as the potential dangers they pose in the universe. It serves as a stark reminder that lurking in the depths of space are entities that challenge our comprehension of gravity, matter, and the very fabric of time itself. Ton 618 is an incredibly massive black hole located far beyond our own galaxy. To put its size into perspective, imagine a black hole that is nearly 30 billion times heavier than our Sun. That staggering mass means it has an immense gravitational influence, far surpassing anything we experience in our own Milky Way galaxy. In contrast, the entire Milky Way, with its billions of stars, gas, dust, and dark matter, has a combined mass of roughly 100 to 200 billion times that of the Sun. Therefore, Ton 618's mass is a significant fraction of our galaxy's total weight, suggesting it would exert a powerful gravitational pull on everything nearby if it were in our cosmic neighborhood. The implications of such mass are profound. A black hole of this magnitude would warp space around it, causing significant gravitational effects on nearby stars and cosmic material. Objects that ventured too close would experience extreme tidal forces, which could tear them apart. Ultimately, such a powerful black hole serves as a reminder of the mysterious and extreme conditions that exist in the universe, far beyond our immediate surroundings. Its sheer mass indicates that it can influence the motion of nearby galaxies and their structures, demonstrating just how interconnected the universe can be. Ton 618 stands as one of the largest black holes ever discovered, a truly formidable presence in the cosmos. Its event horizon is the boundary beyond which nothing can escape. This includes light itself. At this immense threshold, strange and bewildering phenomena may occur, giving rise to spine-chilling mysteries that astound scientists. Imagine approaching this boundary. As you get nearer, the forces of gravity become wildly intense. The black hole's gravity warps not just space around it, but also the flow of time. To an outside observer, it appears as if time slows down drastically for anything crossing this line. If you could witness an object nearing the event horizon, it would seem to hover at that edge, dimming and stretching strangely, almost frozen in time. Yet anyone daring to cross it would be pulled in, never to return. One of the most perplexing mysteries of such a colossal black hole is the concept of Hawking radiation proposed by physicist Stephen Hawking. According to this theory, black holes can emit small amounts of radiation due to quantum effects. This creates an intriguing paradox. If black holes can shrink and potentially evaporate over time, what happens to the information contained within them? The idea that pieces of the universe could simply disappear challenges our very understanding of physics and information preservation. In the shadows of Ton 618, there are also questions about the surrounding environment. The region around black holes is often home to swirling disks of gas and dust spiraling in, heating up to extreme temperatures as they do. This creates bright jets of radiation, possibly allowing us to study the black hole's behavior from a safe distance. The mystery deepens when considering how such massive black holes form in the first place. The origins of Ton 618, of what events birthed such a giant, continue to puzzle scientists. Was it the collapse of a massive star? Or could a series of smaller black holes have merged over time? These captivating mysteries of Ton 618 draw us into a world where the laws of nature as we know them begin to unravel. Each question leads to another, beckoning humans to peer deeper into the cosmic shadows and unveil the secrets that lie beyond. The exploration of these gigantic entities not only expands our knowledge of the universe, but also ignites our imagination about what else could be lurking in the darkness of space. The OJ 287 black hole system holds a fascinating mystery that captivates astronomers and enthusiasts alike. At its core, this system contains two supermassive black holes orbiting each other, much like planets around a star. One of the black holes is significantly larger and is surrounded by an accretion disk filled with gas and dust. As this matter spirals in, it heats up and emits light, creating bright eruptions that we can observe from Earth. What makes OJ 287 particularly intriguing is the predictability of these eruptions. They occur in a regular pattern, similar to clockwork, suggesting a cosmic choreography that differs from randomness. Researchers have observed these outbursts at approximately intervals of a set number of years. This consistent rhythm is a result of the gravitational interactions between the two black holes. As the smaller black hole moves closer to the larger one, it causes disturbances in the accretion disk, leading to bursts of energy and light. This pattern of eruptions makes OJ 287 feel almost alive, creating an eerie sense of timing in the cosmos. Each bright flash acts like a heartbeat, marking the complex dance between the two black holes. For observers, it encourages an appreciation of the vast timescales and intricate motions occurring in the universe. The regularity of these bursts not only helps scientists test theories of gravity, but also highlights the way celestial bodies can influence one another over immense distances, creating rhythms that echo through the fabric of space and time. It serves as a reminder that the universe operates on grand cycles, and within this vast expanse, there exists a sense of order amidst the chaos. In the vastness of space, there exists a binary black hole system where one black hole orbits another. This cosmic duo exhibits periodic outbursts, releasing bursts of energy in ways that baffle scientists. The unsettling enigma lies primarily in the nature of these outbursts. Imagine two massive entities pulling on each other, their gravitational forces creating intense conditions. As material spirals into the black holes, it gets incredibly hot and glows brightly, producing bursts of light and radiation. The periodicity of these eruptions suggests a rhythmic dance between the two black holes, akin to a clock ticking away in the cosmos. However, the exact mechanics of this rhythm remain elusive. Are these outbursts driven by gravitational interactions, or do they hint at more complex behaviors, like the swallowing of gas or stellar debris? Each eruption offers a glimpse into extreme physics at play, revealing clues about the life cycles of stars and the intricate relationships between immense gravitational forces. Scientific models struggle to fully explain these phenomena. The unpredictability and variations in the intensity of the outbursts leave researchers with more questions than answers. What triggers these bursts? How can such powerful phenomena occur in such a confined space? Understanding these periodic outbursts is crucial, as they not only deepen our knowledge of black holes, but also shed light on the fabric of our universe and the fundamental laws of physics that govern it. The mystery of these eruptive events captivates astronomers, driving the quest to decode the cosmic puzzle hidden within this binary black hole system. OJ 287 is a bright and active galaxy located millions of light-years away, known for its extraordinary outbursts caused by the collision of supermassive black holes at its center. Imagine the galaxy as a bustling city, where violent interactions and events create a kind of cosmic chaos. When the two supermassive black holes spiral towards each other, they create immense gravitational forces that can cause significant disturbances, not only in their immediate surroundings, but also across vast distances. These upheavals manifest as dramatic bursts of light and energy. As gas and dust are compressed and heated during the black hole's dance, they emit radiation that can be detected by our telescopes. This is similar to how clashing cars in an intersection can produce loud noises and sparks. Each outburst from OJ 287 can rival the brightness of an entire galaxy, showcasing just how fierce these cosmic interactions are. Additionally, these events can create shock waves, akin to ripples spreading out on a pond after throwing a stone. This demonstrates how one event can influence the rest of the universe. The titanic upheavals in OJ 287 are not just local phenomena, they illustrate the powerful and far-reaching effects of gravity and energy on a cosmic scale. This interplay between black holes reveals the dynamics of the universe, shedding light on the intricate processes that govern celestial interactions. Each flare-up tells a story of collision and chaos, reflecting the relentless processes that shape galaxies and ultimately the cosmos itself. At the heart of our Milky Way galaxy lies Sagittarius A*, a supermassive black hole that has profound implications for both astrophysics and our understanding of the universe. The presence of such a massive entity suggests that galaxies and black holes are intricately interconnected. This connection may reveal how galaxies evolve over time, as the gravitational forces exerted by a supermassive black hole can influence the motion of stars and gas in its vicinity. Sagittarius A** weighs millions of times more than our Sun, and its sheer mass plays a crucial role in the dynamics of the Milky Way. Its gravity helps to bind the galaxy together, acting almost like an anchor that keeps stars orbiting around it. The movement of these stars, especially those close to the black hole, provides scientists with clues about the characteristics of both the black hole itself and the surrounding environment. Moreover, the existence of Sagittarius A** raises intriguing questions about the nature of black holes and the fabric of space-time. Near a supermassive black hole, the predictions of general relativity, Albert Einstein's theory that describes how gravity works, become vital. It challenges our understanding of physics, especially regarding phenomena like the bending of light and the potential effects on time itself. This black hole also serves as a unique laboratory for studying extreme conditions. As matter gets drawn toward it, the interactions produce intense radiation that can be observed with powerful telescopes. These observations help scientists learn more about the processes that govern black holes and their influence on surrounding matter. In a broader sense, the presence of Sagittarius A** in our galaxy emphasizes our place in the universe. It serves as a reminder of the vastness and complexity of cosmic structures. Living in a galaxy with such a mighty force at its center ignites curiosity about the mysteries that lie beyond our world and deepens our appreciation for the intricate dance of celestial bodies through time and space. Sagittarius, a star located at the center of our Milky Way galaxy, is a supermassive black hole, and its influence extends much further than most might think. Imagine the center of a swirling vortex, where the gravitational pull is so strong that it affects everything around it, including our solar system, nearly 26,000 light-years away. This black hole exerts a significant gravitational force on the stars and other objects in its vicinity, creating a gravitational well that can alter the orbits of nearby stars. Over long periods, this means that as stars pass near Sagittarius, a star, their trajectories can change, which could in turn affect the stability of star systems, including ours. If a star were to wander too close to this black hole, the intense gravity could disrupt its path, possibly throwing others in the area out of their stable orbits. Such changes could lead to a chaotic environment in the Milky Way. Imagine a crowded hall where people bump into each other. An unexpected collision can set off a chain reaction that affects many others. One potential consequence for our solar system hinges on the interaction with nearby stars. If a passing star were to get too close, it might perturb the Oort cloud, a vast region of icy bodies that surrounds our solar system. Such an event could send comets hurtling towards the inner solar system, increasing the chances of impacts on Earth or other planets. Additionally, over much longer cosmic timescales, the gravitational dynamics of Sagittarius A star could contribute to a gradual shift in the structure of the galaxy itself. Additionally, over much longer cosmic timescales, the gravitational dynamics of Sagittarius A star could contribute to a gradual shift in the structure of the galaxy itself. Stars can be drawn toward the center, leading to stellar collisions or even the ejection of stars into intergalactic space. If our solar system were to find itself on a path towards such an encounter, it could mean entering a more dangerous and unstable region of the galaxy. While Sagittarius A star is a colossal force at the heart of the Milky Way, its grip extends far beyond its immediate surroundings. The complex interactions it generates over millions and billions of years could create scenarios that may threaten the stability of our solar system, keeping us aware of our place in the vast cosmic dance of the universe. In the center of our galaxy lies Sagittarius A asterisk, a supermassive black hole that captivates scientists and astronomers alike. Surrounding this enigmatic entity are fascinating phenomena that seem almost ghostly in nature. As matter falls towards Sagittarius A asterisk, it creates a swirling disk of gas and dust, known as an accretion disk. This material spirals in at incredible speeds, heating up due to immense gravitational forces and friction. The outcome is the release of high-energy radiation, making the area around the black hole shine with a brightness that can outshine entire galaxies. This powerful light is like a cosmic beacon, hinting at the vast energy generated by the black hole's insatiable hunger for matter. Additionally, nearby objects, including stars, are affected by the black hole's intense gravity. As these stars come close, they can be pulled into highly elliptical orbits. Some stars even seem to vanish from sight as they approach the black hole, sparking curiosity about their ultimate fate. This loss creates an eerie feeling, as if they are being consumed by a dark force. Furthermore, scientists observe powerful jets of energy shooting out from the regions surrounding Sagittarius A asterisk. These jets extend far into space and consist of charged particles moving at nearly the speed of light. The presence of such colossal outflows further illustrates the immense power at play, demonstrating that Sagittarius A asterisk is not just a mere void, but an active participant in shaping its surroundings. These ghostly activities serve as a reminder of the awe-inspiring forces of nature. They reveal an unfathomable power that can warp space and time, influencing everything in its vicinity in ways that challenge our understanding of the universe. M87 asterisk is a supermassive black hole located at the center of the M87 galaxy, and it has earned the nickname the Relentless Devourer for some remarkable reasons. First, black holes like M87 asterisk have an intense gravitational pull that is so strong that nothing, not even light, can escape once it gets too close. This creates a one-way track where anything that strays too near is inevitably pulled in, making it seem almost like a cosmic vacuum cleaner. Its ability to consume matter is extraordinary. M87 asterisk is particularly known for its massive accretion disk. This is the swirling disk of gas, dust, and other stellar debris that spirals into the black hole. As the material spirals inward, it heats up due to friction and emits bright energy, visible even from millions of light years away. This energy produces a striking jet of high-speed particles that shoots away from the black hole's poles, which is a spectacular sight for astronomers studying its surroundings. The relentless nature of M87 asterisk is highlighted not just by its powerful consumption of surrounding objects, but also by its immense size and weight. As one of the largest known black holes, it has a capacity to swallow whole stars and clouds of gas, fundamentally reshaping its galaxy over time. Thus, its haunting abilities truly represent a master of cosmic destruction and transformation, embodying the idea of a force that relentlessly devours everything in its path. Capturing the first ever image of the supermassive black hole at the center of the galaxy M87 marked a monumental achievement in astronomy. This historic image provided a tangible representation of something that was previously only theoretical. Black holes, particularly supermassive ones, are shrouded in mystery. They are regions in space where gravity is so intense that nothing can escape, including light. This means that they cannot be observed directly. By imaging M87*, scientists revealed the presence of a dark shadow surrounded by a bright ring of light. This ring is formed by incredibly hot gas and dust spiraling around the black hole, reaching speeds that cause them to emit light as they accelerate. The shadow itself indicated the presence of the black hole, and seeing it proved that these immense objects exist beyond mere mathematical formulas or simulations. The image deepened our understanding of how supermassive black holes grow and interact with surrounding materials. It confirmed existing theories about the structure and behavior of black holes, providing important insights into their formation and the influence they exert on the galaxies they inhabit. However, it also sparked fear and fascination. The realization that these powerful entities exist in our universe, capable of consuming everything in their vicinity, is both awe-inspiring and unsettling. Beyond just a photograph, this depiction raised questions about the role of supermassive black holes in the cosmic landscape and their potential to affect larger-scale galactic evolution. It serves as a reminder of the unpredictable and often extreme nature of our universe, where such gravitational giants lie within our own galactic neighborhood, lurking in their dark shadows as silent rulers of their domains. The mysterious jet of high-energy particles emanating from the supermassive black hole at the center of the galaxy, M87, is a fascinating phenomenon. Imagine a giant vacuum cleaner sucking in everything around it, only to violently expel forces just as powerful in the opposite direction. This jet, stretching vast distances out into space, is composed of particles traveling at incredible speeds, close to the speed of light, illuminating the dark void of space. The jet is the result of the intense gravitational pull of the black hole, combined with magnetic fields and the surrounding material that gets drawn in. As gas and dust spiral toward the black hole, some of this material is heated to extreme temperatures, creating an environment where particles are accelerated and ejected outward. The secrets concealed within this jet could tell us much about the nature of black holes themselves and their influence on surrounding galaxies. Researchers believe these jets can affect star formation and temperature in the regions surrounding the black hole. As these energetic particles travel, they interact with the interstellar medium, sometimes even triggering shock waves that can create new stars. By studying the composition of the particles in the jet, scientists gather clues about the processes happening near the black hole and gain insights into the fundamental physics of gravity, magnetism, and high-energy environments. The jet serves as a cosmic laboratory, revealing the complex interactions of matter and energy at one of the universe's most extreme locations. Understanding these jets may also provide answers to some of the biggest questions in astrophysics, including the formation and growth of galaxies over cosmic time. In this way, M87's jet serves as a bridge, linking the profound secrets of black holes with the larger structure and evolution of the universe. NGC 1277 is a unique galaxy that has captured the attention of astronomers due to its exceptionally large black hole. Imagine the center of this galaxy as a vast gravitational well where an enormous mass is concentrated. This black hole is not merely a small point, it represents a significant portion of the galaxy's entire mass, a characteristic that sets NGC 1277 apart from most other galaxies. What makes NGC 1277 particularly fascinating is the balance it maintains between this colossal black hole and the surrounding stars. Instead of creating chaos, the black hole quietly influences the movement of stars throughout the galaxy. Think of it like a massive anchor at the center of a ship, where its size shapes the entire vessel's structure and movement. Stars near the black hole orbit it much like planets orbit the sun, but they do so at a much greater speed due to the black hole's immense gravitational pull. The growth of this black hole over time hints at a rich history of cosmic events. It likely began as a smaller black hole that gradually accumulated mass by drawing in gas and stars from its environment. In some cases, it may have merged with other black holes, leading to even more growth. This history reveals how black holes can evolve and dominate their surroundings in a nearly silent manner, impacting the fate of their host galaxies without overt violence. The black hole at the heart of NGC 1277 serves as a reminder of the unseen forces that govern the cosmos. It holds sway over its galaxy, shaping the path of countless stars while remaining hidden in the depths of space. The study of such objects deepens our understanding of how galaxies evolve and the role supermassive black holes play in their development, marking a crucial chapter in the story of the universe itself. NGC 1277 is a giant galaxy, and its remarkable size raises intriguing and unsettling questions about the formation of black holes in the early universe. Generally, we believe that black holes grow gradually, starting small and accumulating mass over billions of years. However, NGC 1277 seems to host a supermassive black hole that is disproportionately large compared to its host galaxy. This suggests that something unusual happened early in cosmic history. One disturbing question is how such a massive black hole could have formed so quickly. Standard theories propose that black holes grow by merging with other black holes, consuming gas and absorbing stars. But NGC 1277 presents a scenario where the black hole appears to have reached an immense size much earlier than expected. This indicates there may have been conditions in the early universe that facilitated more rapid black hole growth. Did some black holes, perhaps forming from the collapse of massive stars, merge together in a way we have yet to fully understand? Another concern arises from the implications of such growth on the surrounding galaxy. With a black hole taking up so much mass, how does it affect star formation? Is it possible that the gravitational pull is strong enough to prevent the galaxy from forming new stars effectively, leading to an imbalance in the ecosystem of the galaxy? Lastly, the existence of such an overgrown black hole prompts questions about the nature of early galaxies themselves. Did they form differently than we currently believe, or were their environments more chaotic? NGC 1277 challenges our understanding of how galaxies and black holes evolved together, making it crucial to explore these anomalies, as they could reshape our perspective on the universe's formative period. NGC 1277 holds a fascinating yet daunting presence in the cosmos. At its center lies an enormous supermassive black hole, which carries a mass millions of times greater than that of our Sun. The chilling aspect of this black hole is how it influences stars around it. Picture the black hole as an immense vacuum, exerting a powerful gravitational pull that can dramatically affect the paths and behaviors of stars within the galaxy. As stars wander too close to this central giant, they risk being drawn in, potentially meeting a fiery demise. This pull disrupts their usual orbits, causing some stars to spiral inward toward the black hole, while others are flung out into more distant regions of the galaxy. The result is a chaotic environment where stellar formations struggle to maintain their stability. Moreover, the presence of such a massive entity at the heart of NGC 1277 can also slow down the rate at which new stars form. This happens because the intense gravitational forces can strip away the gas clouds needed for star creation, leaving the galaxy with fewer new stellar births. Consequently, the galaxy slowly ages as existing stars burn out over time. The dynamic interplay between the black hole and surrounding stars produces a chilling environment where survival is both unpredictable and perilous. NGC 1277 serves as both a cradle of destruction and a limiting factor for stellar evolution, profoundly impacting the fate of its galactic population for billions of years to come. Centaurus A is home to a supermassive black hole at its center, which is surrounded by swirling gas and dust. As material is pulled toward the black hole, some of it doesn't get sucked in. Instead, it gets heated to extreme temperatures and is blasted out in two powerful jets that shoot out from the black hole's poles. These jets are like intense fountains of energy, streaming at almost the speed of light. Imagine a garden hose spraying water, but instead of water, it's made of charged particles and magnetic fields. These jets emerge from the black hole, stretching for enormous distances, often thousands of light years. As they travel through space, they interact with surrounding gas and dust, heating them up and causing them to glow brightly. This creates a striking line or structure that can be observed across the universe. The power of these jets can influence galaxies around them. They can trigger star formation in some areas while suppressing it in others, almost like a cosmic sculptor shaping the environment. The combination of energy, speed, and the sheer scale of the jets from the Centaurus, a black hole, makes them one of the most fascinating features in our universe, etching a dramatic mark across the fabric of space itself. Centaurus A is a fascinating galaxy, located about 12 million light-years away from Earth. At its core lies a supermassive black hole, which is the source of some of the most intense and menacing signals we observe. These signals primarily take the form of powerful jets of energy blasting outward at incredible speeds. Imagine a gigantic water fountain, but instead of water, it's emitting streams of high-energy particles and radiation. Imagine a gigantic water fountain, but instead of water, it's emitting streams of high-energy particles and radiation. As material from the galaxy falls toward this black hole, it spirals in, heating up to extreme temperatures due to friction and gravitational forces. This process generates enormous amounts of energy, which then gets released in the form of X-rays and gamma rays, ultra-energetic light that tells scientists something wild is happening. These emissions are not just a sign of activity, they indicate a formidable force, suggesting interactions that can reshape the surrounding environment. Additionally, the jets from Centaurus A extend far beyond the galaxy itself, spreading outwards into space. The radiation we detect is a clue that this black hole isn't just a passive object, but an active monster, influencing its galactic neighborhood. Its energy output can be so intense that it can affect the formation of new stars and the overall dynamics of the galaxy. Thus, the signals from the heart of Centaurus A are not merely background noise in the universe, they unveil a narrative of cosmic violence and the daunting power of black holes. Centaurus A, positioned about 13 million light-years away, serves as a striking example of how black holes can shape and sometimes devastate their surroundings. This galaxy stands out because it houses a supermassive black hole at its center, which is millions of times more massive than our Sun. This immense gravitational force does more than just create a dark region. It acts as a powerful engine driving the galaxy's evolution and behavior. Imagine a cosmic vacuum cleaner, drawing in gas and dust from its neighborhood. As these materials spiral toward the black hole, they accelerate and heat up, emitting intense radiation that can outshine entire galaxies. This process creates massive jets of energy that shoot out into space at nearly the speed of light. These jets can be incredibly destructive, impacting nearby stars and potentially stripping away their atmospheres. Moreover, the presence of a supermassive black hole can influence the dynamics of an entire galaxy. It can trigger new star formations in some regions due to the shock waves generated by its energetic outflows, while at the same time it can destabilize others, leading to chaos and destruction. This duality highlights the black hole's role not merely as a destroyer, but also as an architect, shaping the life cycle of stars and the structure of galaxies. Yet it's the potential for destruction that often dominates the narrative. As star systems are pulled into the black hole's grasp, they may be torn apart. This creates a devastating cascade of events that reverberates throughout the galaxy. The balance of creation and destruction provides a chilling glimpse into the power of black holes, positioning them as significant forces in the cosmic landscape of Centaurus A, a reminder of the violent universe we inhabit. IC 1101 stands as a staggering giant in the cosmos, recognized as one of the biggest galaxies ever discovered. At its heart lies a supermassive black hole that is both a chilling and fascinating phenomenon. Imagine the black hole as a cosmic vacuum, but one that doesn't just pull in dust and debris. It devours everything in its vicinity, including stars and gas. What makes this black hole particularly chilling is its incredible mass. Picture a weight so immense that it distorts the space around it, creating a gravitational field strong enough to significantly affect the motion of stars and even entire clusters of galaxies. As part of IC 1101, this central black hole serves as a gravitational anchor for the galaxy, ensuring that everything orbits around it. Yet this doesn't mean it's visible in a traditional sense. The black hole itself is entirely dark, only revealing its presence through the effects it has on nearby matter. In addition, its size adds an eerie quality. While most reasonably large galaxies can have central black holes that are hefty, IC 1101's black hole is unmatched, suggesting it has been feasting for billions of years. This concoction of mass and mystery generates a chilling atmosphere. The mere thought of such a monstrous entity lurking at the core of a sprawling collection of stars is enough to spark intrigue and trepidation alike. The black hole is a phantom indeed, its presence felt through the behavior of everything around it, while it remains hidden from direct observation. It symbolizes not just the extremes of cosmic scale, but also the enigmatic nature of the universe itself, leaving us to wonder about the even more profound mysteries that lie beyond our understanding. IC 1101's black hole is a colossal entity that challenges our understanding of the universe and evokes a sense of awe mixed with unease. This black hole is located at the center of a massive galaxy, and its size is staggering. It is believed to be one of the largest black holes known, with a mass that far exceeds many times that of our Sun. To grasp this, imagine a structure so vast that its gravitational pull can influence the movement of countless stars and planets around it. This immense presence reshapes the way we conceive of terror in the cosmos. Normally, black holes are already fearsome, as they can swallow entire stars and warp the fabric of space and time. However, IC 1101's black hole magnifies this dread. The immense gravitational force extends far beyond its immediate vicinity, creating a region where time slows down significantly, a consequence of intense gravitational fields. The closer an object gets to this black hole, the more stretched and distorted reality becomes, creating not only physical danger, but psychological terror. Furthermore, the distance from Earth adds to the eerie nature of IC 1101. It sits over 1 billion light-years away, making it a distant yet potent reminder of our vulnerability in the universe. In the grand cosmos, we are merely specks of dust, existing precariously amid giants like this black hole. The realization that such monstrous entities lurk in the universe encourages a contemplation of our place within it, and highlights the fine line between curiosity and fear when facing the infinite night of space. IC 1101's black hole doesn't just redefine our understanding of size and scale, it serves as a chilling symbol of the unimaginable forces at play in the universe, stirring both fascination and dread about what lies beyond our terrestrial confines. The colossal black hole at the center of a galaxy has unique spectral attributes that reveal much about its nature and influence on cosmic evolution. As light approaches a black hole, much of it is drawn into its gravitational grasp, but some light can escape and provide clues about the black hole's environment. One key aspect is the emission of radiation, particularly in the form of X-rays. When gas and dust from surrounding stellar matter spiral toward the black hole, they become incredibly hot due to the intense gravitational forces. This superheated material emits X-rays, which astronomers can detect. By analyzing these X-ray emissions, scientists can gather important information about the black hole's mass and the dynamics of the material in its vicinity. In addition to X-rays, black holes can also impact light filtering through their surroundings, creating what is known as the accretion disk. The light emitted from this disk can have a range of colors or spectra, depending on the temperatures and speeds of the particles spiraling in. Such spectra can show broad emission lines, indicating turbulent motion and high velocity of the gas near the black hole. Moreover, as black holes grow by consuming surrounding matter, they can affect the movement of stars and gas in their galaxies. This influence is often echoed in the light spectra of nearby stars, revealing shifts in their speed and direction caused by the gravitational effects of the black hole. Overall, the spectral attributes of a black hole are not just indicators of its properties, but also tell tales of its role in shaping galactic evolution, influencing star formation, and dictating the structure of its host galaxy. Each spectral feature observed from afar provides a piece of cosmic history, unraveling the mysterious dance between black holes and the vast fabric of the universe. H1821 plus 643 is a fascinating example of a supermassive black hole that demonstrates the relentless and terrifying nature of these cosmic giants. Located at the heart of a galaxy, H1821 plus 643 has an extraordinary ability to consume nearby matter. Imagine an insatiable vacuum cleaner that never fills up. This black hole pulls in gas, dust, and even stars that come too close, swallowing them whole. As matter spirals toward H1821 plus 643, it forms a disk around the black hole, known as an accretion disk. This disk is incredibly hot and bright, radiating intense energy as friction heats the material to extreme temperatures. Here, we witness the terrifying power of gravity at work, where the forces acting on the material become so great that they create blinding light visible across vast distances. The insatiable nature of H1821 plus 643 also reveals the potential danger black holes pose to their surroundings. When nearby objects approach, they can find themselves on a one-way trip into darkness with little hope of escape. As they cross the boundary known as the event horizon, the point of no return, they vanish from our universe, lost forever. This illustrates the unforgiving aspect of black holes. They exert a gravitational grip that compresses space and time, creating a region where conventional rules seem to break down. The consumption of nearby matter also impacts the galaxy around H1821 plus 643, influencing star formation and altering the fate of countless celestial bodies. This black hole is a reminder of the dynamic and sometimes violent nature of the universe. While they might seem distant and abstract, the effects of such immense forces can cascade through space, reshaping entire galaxies over time. The terrifying reality of black holes like H1821 plus 643 invites us to explore the intricate balance of creation and destruction that defines our cosmos. Quasars are among the most luminous objects in the universe, and H1821 plus 643 is no exception. Imagine a point in space that is millions of times brighter than our entire galaxy, a dazzling beacon that signals immense energy production. H1821 plus 643 is a supermassive black hole at the center of a distant galaxy, feeding on surrounding gas and dust. As this material spirals into the black hole, it forms an accretion disk, heating up to incredible temperatures due to friction and gravitational forces. As the gas and matter accelerate, they emit energy across the spectrum, from radio waves to visible light to even X-rays. This intense release of energy is what makes quasars, including H1821 plus 643, shine so brightly. The brightness of H1821 plus 643 indicates not only the vast amount of material it consumes, but also the overwhelming gravitational forces at play. The activity of H1821 plus 643 serves as a reminder of the universe's extremes. The immense gravitational pull of the black hole draws gas at astonishing speeds, resulting in jets of particles being ejected at nearly the speed of light from its poles. These jets can stretch across vast distances into the surrounding space, illuminating the environment with their high-energy emissions. The very existence of H1821 plus 643 challenges our understanding of how black holes and galaxies evolve. Its brightness is a signal of the fierce power hidden within a supermassive black hole, teaching us about the processes that shape the cosmos, even when they are millions of light-years away. H1821 plus 643 not only represents a marvel of nature, but also opens a window to understanding the vast forces at work in the universe. The immense size of H1821 plus 643, a giant black hole located in a distant galaxy, offers crucial insights into how supermassive black holes grow over time. Imagine a space where such a massive black hole can swallow stars and gas, drawing vast amounts of material toward it. Its sheer scale challenges our understanding of how black holes developed and evolved, suggesting they could grow faster and larger than previously thought. The size of H1821 plus 643 indicates that the growth of supermassive black holes may have involved significant mergers with other black holes and the accumulation of gas from their surroundings. This means that rather than growing slowly, some black holes might experience bursts of rapid growth during specific cosmic events. As H1821 plus 643 is so large, it serves as an example that can help scientists evaluate the processes that lead to such a magnitude. Furthermore, studying H1821 plus 643 pushes researchers to reconsider the relationship between black holes and their host galaxies. The dynamic interactions between them might play a critical role in enabling black holes to gather the necessary materials to grow significantly. The discovery of such massive black holes raises questions about the formation of galaxies and the environments that support these cosmic giants. By examining H1821 plus 643, scientists can refine their models and theories about the life cycle of supermassive black holes, leading to a deeper understanding of the universe's history and the evolution of its most enigmatic objects. The black hole at the center of S50014 plus 81 is not just any black hole, it is a supermassive one, demonstrating astonishing characteristics that captivate scientists and astronomers alike. This black hole is surrounded by an accretion disk made up of gas and dust spiraling around it at incredible speeds. The friction and heat generated by this material create an immense amount of energy, making S50014 plus 81 one of the brightest objects in the universe. What makes this black hole particularly terrifying is its ability to release energy in the form of jets. These jets shoot out from the poles of the black hole at nearly the speed of light. They carry high-energy particles and radiation far into space, affecting the environment around them. Imagine a cosmic firework display where streams of light and energy burst forth, illuminating the darkness of the universe. The gravitational force near this black hole is also extreme. Anything that ventures too close faces the risk of being stretched and compressed in a way that defies comprehension, a process termed spaghettification. This phenomenon occurs as the gravity feels significantly stronger on one side of an object than on the other, pulling it apart like strings of spaghetti. The sheer size of the black hole itself, with a mass millions to billions of times that of our Sun, exerts a massive influence on its surroundings. It draws in material, which fuels the continuous process of energetic outflows. This energetic behavior not only impacts nearby stars and gas, but can also influence the formation of galaxies over time. The black hole at the core of S50014 plus 81 stands out for its immense energy output, powerful jets that radiate vast distances, extreme gravitational forces that can tear apart objects, and its significant role in shaping the cosmic environment. Each of these characteristics paints a picture of a force that is both fascinating and fearsome, illuminating the depths of our universe while posing numerous mysteries yet to be unraveled. S50014 plus 81 is a fascinating object located billions of light-years away from Earth. At its core, it hosts a supermassive black hole that seems to pull in a tremendous amount of gas and dust. As this material spirals toward the black hole, it accelerates and heats up, creating an extraordinarily bright region known as a quasar. Imagine the quasar as a beacon of light in the vast darkness of space. This incredible brightness is not just an impressive display, it serves as a powerful tool for scientists. The light emitted from the quasar travels through space and reaches us, carrying valuable information about its surroundings. Because the quasar is so bright, we can study it even from such great distances. This allows researchers to observe the effects of the black hole on the material around it, and the nature of the space between us. Interestingly, the brightness also helps us understand the structure of the universe itself. As that blinding light travels through the cosmos, it encounters various materials, like gas clouds and dark matter. Each time it interacts, parts of its light can be absorbed or scattered, altering the way the quasar appears to us. By studying these changes, scientists can infer the presence of otherwise invisible components in the universe, which contribute to our understanding of its makeup. The glow of S50014 plus 81 provides a glimpse into the terrifying void around it, revealing not only the nature of the black hole itself, but also the cosmic environment that exists in the far reaches of space. It's a striking reminder of how powerful and insightful the universe can be, even amidst its most shadowy corners. When an object gets pulled into a black hole, it embarks on a journey into one of the universe's most mysterious phenomena. As the object approaches the black hole, it encounters an incredible gravitational force that escalates rapidly. This pull becomes so strong that it can surpass any counteracting forces, such as the object's momentum or any energy it might have. Imagine stretching a rubber band. As you pull it tighter, the tension increases. Now, envision this tension not just stretching, but intensifying beyond any limits. This is similar to what happens to the object. The closer it gets to the black hole, the more pronounced the differences in gravitational force become. This is known as tidal forces. For an object on a collision course, one side, which is nearer to the black hole, feels a significantly stronger pull than the other side. This difference can stretch the object in a process called spaghettification, where it gets elongated like spaghetti. Once the object crosses the boundary called the event horizon, it enters a realm from which nothing can escape, not even light. In this moment, the object becomes part of the black hole's interior and disappears from the view of the outside universe. The event horizon itself is like a one-way street. Once you enter, returning or sending signals back is impossible. Inside the black hole, the laws of physics as we know them begin to break down. Scientists aren't entirely sure what happens at the very center, known as the singularity, where all the mass of the black hole is thought to be concentrated. Here, gravity is thought to become infinitely strong, and the usual rules of space and time may not apply. As we ponder what happens to such objects, we find ourselves at the edge of our understanding, where the universe holds secrets we are only beginning to grasp. Each plunge into a black hole represents a glimpse into the complexities and unknowns of cosmic laws that govern our reality. The discovery of one of the largest cosmic explosions linked to the Ophiuchus black hole began with unexpected observations. Scientists first noticed a unique feature in the Ophiuchus cluster, which is a massive grouping of galaxies. They observed enormous amounts of energy being released in a region where a supermassive black hole resides at the center. This black hole, situated around 39,000 million times the mass of the Sun, plays a central role in the dynamics of the entire cluster. The terrifying evidence emerged from X-ray data collected by space telescopes. These observations revealed an unusual cooling pattern of hot gas surrounding the black hole. Normally, this gas should have remained at a stable temperature, but the presence of large shock waves indicated that something significant had disturbed it. Astronomers theorized that the black hole had unleashed a colossal explosion, sending shock waves through the surrounding material. As they investigated further, scientists recognized that these shock waves were pushing colder gas away from the center. The results were staggering. This, along with the tremendous energy release, signified an unprecedented outburst. This explosion was so immense that it could be seen across vast distances, shedding light on the destructive power of black holes and their capability to influence entire galaxy clusters. The terrifying evidence of this explosion served as a reminder of how dynamic and violent the universe can be, revealing a phenomenon that defies our understanding of cosmic events on such a grand scale. The Ophiuchus black hole not only showcases the terrifying might of gravitational forces, but also emphasizes the intricate connections between black holes, galaxies, and the fabric of space itself. The power of a black hole to create tremendous explosions fills us with both wonder and dread. When a black hole pulls in matter, such as gas from a nearby star, it heats that material to incredibly high temperatures as it spirals inward. This process unleashes energy so intense that it can produce dazzling bursts of radiation. Imagine a cosmic furnace. As materials are consumed, they glow fiercely and emit light far beyond what we can see with our eyes. This can result in extraordinary phenomena such as jets shooting out at nearly the speed of light, creating spectacular displays in the sky. The awe arises from the sheer scale and energy involved. These explosions demonstrate the incredible forces of nature, showcasing how something as dense as a black hole can affect its surroundings in powerful ways. The beauty of these phenomena captivates astronomers and space enthusiasts alike, serving as a reminder of the universe's endless mysteries. However, this spectacle also instills fear. The might of a black hole is overwhelming and can disrupt entire star systems. Should our planet drift too close to one of these cosmic giants, the gravitational forces could tear it apart. The thought of being consumed by such an immense power evokes a primal fear of the unknown. Black holes embody both the brilliance of cosmic phenomena and the terrifying reality of their potential destructive capabilities, making them one of the most fascinating and frightening aspects of our universe. The Ophiuchus explosion is an astounding event that showcases the extraordinary power hidden within black holes. Imagine a colossal explosion occurring in a cluster of galaxies, releasing energy that's equivalent to the energy output of millions of suns. This event reveals how black holes can unleash immense forces, transforming their surroundings incredibly. At the heart of a black hole lies a singularity, an area where gravity is so strong that nothing can escape its pull. When matter falls into a black hole, it doesn't just disappear. Some of it gets heated up to extreme temperatures before being swallowed completely. This heating process creates vast amounts of energy, which can then be ejected out into space in the form of jets of particles traveling nearly at the speed of light. The Ophiuchus explosion serves as a vivid illustration of how these jets can create shock waves that propagate through intergalactic space, interacting with other matter and gas. This interaction generates spectacular bursts of energy and prevents new stars from forming in the region. The power of a black hole is not merely a function of its mass, it involves the dynamics of how it interacts with its environment. The Ophiuchus explosion reveals that black holes are not just lonely entities lurking in the cosmos. They are active players in shaping the fate of galaxies, affecting star formation, and influencing the structure of the universe. This dramatic event acts as a reminder of the complexity of cosmic interactions and the wild, often unpredictable nature of astronomical phenomena. Through understanding such explosions, we continue to unveil the profound mysteries behind the universe's most powerful forces. The black hole in APM 08279 plus 5255 is extraordinary in ways that stretch our imagination about the universe. It is one of the largest known black holes, situated in an enormous galaxy far away from our own. To grasp its size, envision a region with the mass equivalent to more than 1 billion suns packed into a space so small that nothing can escape its gravitational pull, not even light. Imagine being near such a massive entity, where the gravitational force is so powerful that it warps the surrounding fabric of space and time. This black hole doesn't just alter its immediate environment, it significantly influences the entire galaxy around it. Stars in its vicinity experience great changes in their orbits, getting pulled in with dramatic ferocity, while the galaxy itself seems to revolve on a larger scale around this colossal force. Witnessing the impact of a black hole of this magnitude can evoke a sense of dread, like a cosmic predator lurking in the darkness, constantly consuming matter and energy. Surrounding gas and dust swirl frantically, forming an accretion disk that glows brightly as it heats up from friction, signaling the presence of this cosmic giant. The very existence of APM 08279 plus 5255 serves as a reminder of how small we are in the grand scale of the cosmos. It highlights the terrifying reality that in the universe there are forces far beyond human comprehension, reminding us that we are but tiny specks in a vast and often hostile expanse filled with unimaginable wonders and dangers. The sheer scale of this black hole not only challenges our understanding of space, but also evokes a profound sense of awe and humility in the face of the universe's mysteries. Black holes are not just mysterious voids in space, they create a variety of astonishing phenomena that contribute to their fearsome reputation. Surrounding a black hole is an area known as the accretion disk. This disk consists of gas, dust, and other materials spiraling inwards, creating an intense swirl of energy. As these materials fall in, they heat up due to friction and gravitational forces, often reaching incredible temperatures. This superheated material emits light, making the black hole visible in certain wavelengths like X-rays, illuminating its presence in the darkness of space. Moreover, black holes can produce powerful jets that shoot away from the poles at nearly the speed of light. These jets are driven by the magnetic field generated in the accretion disk, sending particles outwards over vast distances. Such high-energy jets can affect surrounding galaxies and influence the growth of stars, showcasing the black hole's extraordinary reach and power. Gravitational waves are another aspect of a black hole's monstrous nature. When black holes collide or merge, they create ripples in the fabric of space-time. These gravitational waves travel outwards at the speed of light, causing tiny distortions as they pass through the universe. The detection of gravitational waves has provided critical insights into the nature of black holes and their collisions, adding a layer of awe to their already impressive presence. All these phenomena, radiating energy from the accretion disk, explosive jets, and the generation of gravitational waves, combine to forge the black hole's fearsome reputation. They illustrate not only the destructive potential of these cosmic giants, but also their vital role in shaping the universe itself. The more we study these effects, the more we realize that black holes are not merely points of no return. They are dynamic engines of change and energy in the universe. The discovery of massive black holes at the centers of many galaxies transforms our understanding of the universe in significant ways. Black holes are regions in space where gravity pulls so strongly that nothing, not even light, can escape their grasp. When we encounter these colossal entities, some of which are millions or even billions of times the mass of our Sun, it raises important questions about the very structure of our cosmos. Firstly, the existence of such massive black holes challenges the traditional view of galaxy formation. We used to think galaxies formed from the slow accumulation of matter. However, these giant black holes suggest that they might play a crucial role in shaping their host galaxies right from the beginning. It is as if they act as anchors, influencing how stars and other materials gather around them. At the heart of the galaxy known as Holm 15, A lies a supermassive black hole, a region of space where gravity is so intense that not even light can escape its clutches. This black hole has a presence that feels both extreme and ghost-like, shaping the dynamics of the surrounding galaxy in a profound way. The key factor driving this phenomenon is its immense mass. Picture a massive object, so heavy that it pulls everything around it into its gravitational embrace. The black hole at Holm 15A is one of the largest known, containing billions of times the mass of our Sun, creating a gravitational force that dramatically influences the motion of nearby stars and gas. As material spirals toward the black hole, it forms an accretion disk, a swirling collection of gas and dust. This disk heats up to incredibly high temperatures due to friction, emitting powerful radiation that can shine brightly even from great distances. However, at the center of the black hole lies the event horizon, the point of no return. Beyond this threshold, anything that ventures too close is consumed, adding to the black hole's mass and reinforcing its ghostly nature. This creates a situation where the black hole is imperceptible against the dark backdrop of space, visible only through its effects on nearby objects. The black hole's influence extends beyond just its immediate vicinity. Its presence shapes the overall structure and behavior of the galaxy, dictating how stars form and interact in the sprawling environment of Holm 15A. The combination of its massive gravitational pull and the haunting silence of what lies beyond the event horizon gives it a presence that captivates and intrigues astronomers and enthusiasts alike, marking it as a remarkable and enigmatic feature in our universe. Holm 15A is home to a supermassive black hole that remains shrouded in mystery. Despite its massive size, this black hole does not glow with light like stars do. This lack of visibility creates an eerie feeling, as it seems to lurk just out of sight, much like a predator hiding in the shadows. The surrounding star cluster exhibits a vibrant display of color and motion, yet the black hole exerts an unseen power over its environment. To understand why this is unsettling, consider that black holes are incredibly dense and exert immense gravitational forces. They can pull in everything around them, including gas, dust, and even entire stars. This power can lead to dramatic effects in the galaxy, such as the destabilization of nearby stars or the gradual consumption of celestial objects. Because we cannot see the black hole itself, we are left with the unsettling notion that something immense and potentially destructive is silently governing the dynamics of the galaxy. Additionally, the absence of light from the black hole means we must rely on indirect evidence, like the movement of stars, to understand its presence. This reliance creates a sense of uncertainty. When we cannot see the source of gravitational pulls or the swallowing of matter, it sparks our imagination about what might happen. Could it strike unexpectedly? Will it disrupt the formation of new stars? This duality of awe and fear, mixed with the mystery of the unseen, evokes a genuine sense of lurking danger, reminding us of the vast, unpredictable forces at play in the universe. Black holes challenge our conventional understanding of the universe in profound ways. They are not just enormous vacuums. Instead, they represent regions of space where gravity is so strong that nothing can escape once it crosses a certain boundary called the event horizon. This defiance of our everyday experiences raises unsettling questions about the nature of reality itself. When scientists study these cosmic giants, they find that the laws of physics as we know them break down at their centers, known as singularities. This suggests that our current understanding of gravity, space, and time might be incomplete. The immense gravitational pull of black holes can also inspire fear in cosmic exploration. Imagine being drawn toward a powerful force without a way of returning. Spacecraft approaching a black hole would be caught in its gravitational grasp, making escape impossible. The idea of being consumed by such a formidable entity evokes a sense of vulnerability. They are the ultimate trap in the vastness of space, where light itself cannot travel away from their grasp. Moreover, black holes challenge our concept of time. As one moves closer to a black hole, time behaves unusually. For an observer near it, time slows down compared to someone far away. This distortion sparks a fear that our experiences of time could be altered in ways difficult to comprehend, bending the very fabric of our reality. The enigmatic nature of black holes fuels not only scientific curiosity, but also a primal fear of the unknown. The more we learn, the more we realize how little we understand. This imbalance draws us in, pushing the limits of exploration, while the potential dangers remind us of the unpredictability of the cosmos. Black holes stand as silent reminders of the vast mysteries that lie beyond our reach, stirring both awe and trepidation in the pursuit of knowledge. The black hole in NGC 1600 holds a significant yet often invisible influence over its entire galaxy. At the center of NGC 1600 lies a supermassive black hole, an entity millions of times the mass of our Sun. This immense gravitational force exerts a silent power, affecting the stars and gas that surround it. As objects spiral around the black hole, their motion is altered by its gravity, creating a gravitational dance that shapes the dynamics of the galaxy. The black hole's interaction with nearby stars can lead to the formation of new stellar orbits and gravitational pulls, subtly changing their paths over time. Because black holes are primarily detected through their effects rather than direct observation, this influence can be mysterious and difficult to measure. This power also affects the rate of star formation in NGC 1600. The black hole can expel gas from the central region through energetic processes, such as jets of particles moving at extremely high speeds. When gas is removed, there is simply less material available to form new stars. This balance plays a crucial role in the life cycle of the galaxy, determining how vibrant or quiescent it appears over time. The black hole in NGC 1600 acts as a silent architect of its galaxy, shaping the structure and evolution of stars and the interstellar medium. This influence implies that the unseen forces at the heart of galaxies can have far-reaching consequences, helping astronomers understand not just the black hole itself, but also the broader cosmic environment surrounding it. Such insights reveal the interconnectedness of celestial bodies and the balancing act between creation and destruction in the vast universe. NGC 1600 is a fascinating galaxy housing a supermassive black hole at its center. Despite its presence, this black hole has managed to remain largely hidden from our view. One significant reason for this obscurity is the way it interacts with its surroundings. Unlike active black holes that consume material, emitting bright radiation visible across vast distances, NGC 1600's black hole is dormant. It doesn't actively pull in gas and dust at a high rate, which means it does not produce the bright light typically associated with black holes. Another factor is the galaxy's composition. NGC 1600 is a giant elliptical galaxy with a dense core containing a massive amount of stars packed closely together. The light from these stars can obscure the black hole, making it difficult for astronomers to detect it against the backdrop of the glowing stellar environment. Additionally, the very nature of black holes makes detection challenging. They do not emit light. Instead, their presence is often inferred through the effects they have on nearby stars. In the case of NGC 1600, it took advanced telescopes and careful measurements of the motion of stars surrounding the black hole to reveal its mass and existence. This method requires precise observations over time, which can be a lengthy process. The combination of a dormant state, a crowded galactic environment, and the inherent properties of black holes has allowed NGC 1600's central black hole to stay concealed for so long. It illustrates how even massive objects lurking in our cosmic neighborhood can evade discovery when they don't fit the usual profiles of their more active counterparts. The discovery of a dormant yet massive black hole offers fascinating insights into the universe's hidden structures. It suggests that there may be more of these colossal entities lurking in the cosmos than previously thought. A dormant black hole is one that is not currently consuming material or actively shining brightly, yet it still maintains an impressive gravitational pull. This discovery implies that the formation of black holes can occur in situations where they are surrounded by little matter, making them difficult to detect. It raises the possibility that many massive black holes exist in a state of quiet, waiting for the right conditions to become active. If one large black hole can remain unnoticed, it stands to reason that others could also be hidden in the vastness of space. Exploring the nighttime sky, astronomers may find evidence of these giants by studying their surroundings. For example, if they detect stars moving in unusual orbits, it might signal the gravitational influence of a black hole nearby. Consequently, the presence of dormant black holes could suggest a vast unseen population within our galaxy and beyond, leading to a significant re-evaluation of how we understand black holes and their life cycle. This potential abundance opens up new areas for research and challenges our understanding of how these fascinating objects form and evolve across the universe. Scar A East is notably different from standard black holes, primarily due to its massive scale and the energy it has released in its past. While typical black holes are defined mainly by their immense gravitational pull and the fact that they absorb nearby matter, Scar A East reveals a history marked by explosive activity and intriguing origins. Located at the center of our Milky Way galaxy, Scar A East is believed to be associated with a supernova explosion, a cataclysmic event resulting from the death of a massive star. This explosion expelled vast quantities of matter and energy into space, creating dynamic interactions with the surrounding environment. Unlike a more conventional, isolated black hole, Scar A East exhibits remnants that tell a story of cosmic violence, showcasing shockwaves and heated gas that can potentially shine brightly in X-ray light. The presence of these explosive remnants makes Scar A East unique. The remnants consist of particles and radiation, providing clues about the events that shaped it, whereas typical black holes tend to remain more enigmatic, often consuming matter without leaving visible signs of their influence. Furthermore, Scar A East also serves as a window into understanding the nature of black holes within their galactic environments. It highlights the interconnectedness between black holes, their surrounding stars, and interstellar gas. By studying this particular region, scientists can gain insights into the complex life cycles of stars and the dynamic processes that govern our galaxy. Scar A East represents not just a singular black hole, but a cosmic narrative of birth, death, and rebirth within the tapestry of the universe. Scar A East is a prominent feature in the center of our galaxy, marked by the remnants of a massive explosion known as a supernova. Imagine a colossal star that reached the end of its life cycle, collapsing under its own gravity before erupting in a cataclysmic explosion. This process didn't just wipe out the star, it scattered its outer layers into space, creating a stunning structure that hints at its violent past. The remnants of this explosion are visible in various forms, including an expanding shell of gas that glows with energy as it interacts with surrounding material. Observers can detect this shell using different wavelengths of light, painting a vivid picture of the dynamic forces at play. In addition to the gas, we also find evidence of shock waves created by the explosion, sending ripples of energy through nearby space. This activity continues long after the initial explosion, creating an environment that is turbulent yet rich in stellar material. What's truly eerie is the presence of dust and gas that remain from the explosion, remnants slowly drifting and mixing with other cosmic elements. These materials serve as a reminder of the violent history that has shaped our galaxy, with Scar A East standing as a testament to the cycles of death and rebirth in the universe. Each of these features encapsulates a story of destruction and the potential for new star formation, hinting at the impacts of one cataclysm on the broader cosmic landscape, which continues to influence the environment in the region even millions of years later. To comprehend the secrets of Cigar A East, which is a satellite of the supermassive black hole at the center of our galaxy, scientists rely on the study of light, more specifically its spectrum. Light can reveal a wealth of information about celestial objects, acting like a fingerprint that tells us about their composition, temperature, and movements. When astronomers observe the light emitted or absorbed by Cigar A East, they analyze the spectrum, which contains various colors that correspond to different wavelengths. Each color reveals different elements present, much like looking at the ingredients in a recipe. For instance, specific patterns in the spectrum indicate the presence of high-energy processes, which hint at the violent activity taking place there. As these spectra are gathered through powerful telescopes and complex instruments, researchers look for shifts in the light, known as Doppler shifts. This phenomenon occurs when an object moves relative to the observer. If Cigar A East is moving towards us, the light waves are compressed, shifting towards the blue. If it moves away, the light stretches, shifting towards the red. These shifts help scientists measure the speed of the object and infer how much energy is being released. Additionally, scientists study various forms of radiation, from radio waves to X-rays, which come from different processes occurring in the region around Cigar A East. Each type of radiation can tell a unique story about energetic jets emerging from the region and how matter behaves in such extreme conditions. By piecing together this spectral information, astronomers build a clearer picture of Cigar A East's capabilities. They grasp how it interacts with surrounding matter, as well as its role in forming bursts of energy that could be quite terrifying. Understanding this spectral history not only showcases the ferocity of Cigar A East, but also unravels the broader phenomena that occur near supermassive black holes, providing key insights into the workings of our universe. The black hole in a 2261 BCG, located at the center of a giant galaxy cluster, embodies both a sense of timelessness and immense power. To understand this, imagine the black hole as a massive engine of gravity, consuming everything that ventures too close. This process is not only a cosmic catastrophe, but also part of a cycle that has occurred over billions of years, demonstrating a timelessness that transcends human understanding. This black hole weighs as much as billions of suns, making it one of the largest known. Its sheer mass signifies not just gravitational strength, but the capability to influence its surroundings in extraordinary ways. As it pulls in matter, it releases tremendous energy in the form of radiation, shaping the environment around it. This energy can heat surrounding gas to millions of degrees, creating powerful jets that shoot out into space, impacting other galaxies and even the cosmic web itself. The power of the black hole is also tied to its role in the evolution of galaxies. It acts as a core force, regulating star formation by affecting the flow of gas in the galaxy. The balance of material falling into the black hole versus that which is ejected creates a dynamic ecosystem, one where growth and destruction coexist. Furthermore, the black hole in a 2261 BCG suggests untapped power in numerous potential ways. For example, researchers are still uncovering knowledge about how these celestial giants affect their cluster environment over vast timescales. Understanding this complex interplay could unlock insights into the formation of the universe itself, revealing the processes that govern cosmic evolution. This black hole stands as a timeless monument, illustrating the continuous dance of creation and destruction within the universe, while holding secrets that challenge our understanding of physics and cosmology. Its existence invites inquiry into the fundamental nature of reality, making it a profound object of study with power that remains largely mysterious. The absence of a black hole, especially in a region where one is expected to exist, leads to intriguing questions about its status. Imagine looking for a crucial piece of a puzzle that should be there, yet is nowhere to be found. Scientists often detect black holes through their effects on nearby stars and gas, pulling them with strong gravitational forces. If a black hole is missing, it suggests that something unusual has occurred. One possibility could be that the black hole has moved. Black holes aren't stationary. They can acquire enough momentum from interactions with other celestial bodies or events like supernovae, causing them to drift away from their original location. Additionally, It raises questions about whether the black hole has merged with another, creating a larger black hole that might not be detected in ways typical for smaller ones. Another unsettling thought is that the black hole might have evaporated, though this is based on theories that suggest very tiny black holes can lose mass over time through a process described as Hawking radiation. This phenomenon suggests that, given enough time, even a black hole could vanish entirely. These scenarios compel scientists to rethink their understanding of black holes and the dynamic nature of the universe. Each missing black hole presents an opportunity to delve deeper into the processes governing these mysterious cosmic entities, sparking curiosity and leading to more questions than answers. What really happens to black holes over time, and how does their existence, or potential non-existence, impact our overall understanding of the cosmos? The story of A2261, BCG's central black hole, presents a captivating glimpse into the mysteries surrounding these enigmatic cosmic entities. A 2261 BCG is located at the heart of a massive galaxy cluster, and its black hole is particularly striking because of its vast size. Observations suggest that this black hole might hold a mass over 1 billion times that of our Sun, making it one of the largest known. What makes A2261, BCG's central black hole, even more intriguing is its behavior and influence on the surrounding environment. Typically, black holes are thought to siphon off material, consuming gas and stars in their vicinity. However, this black hole appears to have a unique relationship with its surroundings. Instead of simply absorbing matter, it is believed to expel energy and powerful jets of material. These jets can influence star formation in the galaxy, acting like a cosmic feedback system that shapes the environment. This dual role raises questions about how black holes evolve and the ways they interact with their host galaxies. One important takeaway is that black holes do more than just devour. They play a crucial role in cosmic ecology. They affect not only their immediate surroundings, but also the larger structures of galaxies, influencing star formation and the behavior of gas clouds. The case of a 2261 BCG highlights the dynamic nature of black holes and reminds us that they are not isolated phenomena. Instead, they are central players in the intricate dance of cosmic evolution, continuously shaping and reshaping the universe around them. Their puzzling behaviors not only fuel scientific inquiry, but also capture our imagination, compelling us to explore and understand the depths of their mysteries. The discovery of a rapidly moving black hole like 3C186 can stir intense feelings and provoke thoughts about the end of the universe. Imagine an object so dense that its gravitational pull is incredibly strong, swirling around and racing through space. This particular black hole is moving at an astonishing speed, which means it is not simply remaining in place, but is instead tearing through the cosmos, consuming everything in its path. The apocalyptic visions often arise from our understanding of black holes in general, as they can be seen as cosmic vacuum cleaners. When we picture a black hole moving rapidly, it may seem like a menace that could disrupt the balance of surrounding stars and galaxies. This distorted image evokes a sense of impending doom, as if the universe's delicate structure could be unraveled at any moment. Additionally, because black holes can warp space and time, the unpredictability of their presence adds to the feelings of chaos and destruction. If one were to approach such a powerful and swift entity, they would experience extreme gravitational effects, leading to what scientists call spaghettification, where objects are stretched and torn apart. Such imagery can easily be interpreted as a catastrophic event, reminiscent of apocalyptic scenarios where destruction is imminent. Furthermore, when scientists observe black holes like 3C186 moving at great speeds, it challenges our understanding of the universe's stability. Each discovery can reveal more about cosmic forces and behaviors that humans have yet to fully comprehend, prompting thoughts about our own existence in an ever-changing universe. These elements combined, mystery, potential chaos, and the insignificance of our position in the vast cosmos, contribute to the evocative, almost fearful visions associated with these celestial giants. The discovery of a black hole situated far away from its host galaxy raises intriguing implications for our understanding of the universe. Typically, black holes are found at the centers of galaxies, where they can influence the movement of nearby stars and gas. When a black hole is detected far from its expected location, it prompts scientists to consider several possibilities about its origin. One key implication is that this black hole may have been part of a galaxy that was destroyed or altered in some way. For example, a galaxy could have merged with another, leading to the ejection of the black hole into intergalactic space. This scenario suggests that black holes might not only form from the remains of massive stars at the end of their life cycles, but also through complex interactions during cosmic events. Another possibility is that this black hole could have formed in isolation from the collapse of a massive star in a place without significant galactic influence. This challenges our existing models about the environments where black holes develop and could indicate that these fascinating objects are more common than previously thought. Additionally, the presence of a lone black hole opens questions about the dynamics of galaxies. If black holes can exist detached from galaxies, it suggests that they may play a role in the gravitational interactions of the surrounding universe. Such black holes could affect the movement of stars and gas in their vicinity, potentially altering the behavior of neighboring galaxies. Moreover, understanding why this black hole is so far from its home galaxy can help narrow down the conditions under which black holes evolve. It can lead to new insights about dark matter and dark energy, which still remain largely enigmatic. Finally, studying displaced black holes could shed light on the nature of gravitational waves. When black holes merge, they emit ripples in space-time that can be detected by observatories. Observing a black hole in an unexpected position might hint at past gravitational wave events, providing valuable information about the history of cosmic collisions and the dynamics of black hole formation. The detection of a black hole away from its galaxy speaks volumes to the intricacies of cosmic evolution, unveiling questions about black hole origins, galactic interactions, and the fundamental workings of our universe. Scientists observe 3C186, a distant quasar, with fascination and apprehension due to its immense energy and the implications of its behavior. This quasar is powered by a supermassive black hole, which is actively consuming material from its surroundings at a staggering rate. The energy released during this process is so intense that it outshines entire galaxies. The cataclysmic aspect arises from the immense gravitational forces involved. As matter spirals into the black hole, it doesn't just vanish, it creates powerful jets that can shoot out into space, traveling at speeds incredible enough to distort the fabric of space-time itself. These jets aren't just harmless streams of gas, but could potentially impact surrounding galaxies, if aimed in their direction. The journey of 3C186 through space isn't just a solitary event. It is part of a broader cosmic tapestry, influenced by the gravitational pull of nearby objects and potential interactions with other celestial phenomena. If it were to collide with another galaxy, the consequences could be profound. This could trigger a burst of star formation or unleash gravitational turbulence that disturbs the orbits of nearby stars and planets, potentially leading to severe cosmic disruptions. For scientists, interpreting these scenarios emphasizes the balance between the awe of the universe's vastness and the chaos that can arise within it. Each observation of 3C186 adds pieces to the puzzle of black hole physics and the role these titanic forces play in the evolution of galaxies and the universe itself. The implications of such celestial behavior remind us that while we are small inputs in a grand cosmic equation, the events occurring in the universe can have far-reaching effects, often beyond our current understanding. The mystery of the missing black hole in the galaxy cluster, Able 2261, weaves a tale that captures both intrigue and a sense of cosmic horror. Within this vast cluster, astronomers expect to find a supermassive black hole at the center of the biggest galaxy, just as they do in many large galaxies throughout the universe. This black hole is typically the beacon of gravity, influencing the motion of stars and gas around it. However, in Able 2261, this expected black hole appears to be absent, creating an eerie blank space in what should be a dynamic cosmic landscape. The absence of this gravitational anchor raises unsettling questions. Where did it go? Black holes generally grow by consuming matter from their surroundings, but in this case, it seems like the largest galaxy lost its central point of gravity. One possibility is that the black hole may have merged with another, but this scenario becomes unsettling when we consider that such events can lead to catastrophic ejections of powerful gravitational waves, which would act like ripples in the fabric of space-time. Alternatively, the black hole might be hidden, masking its presence in a way that defies our understanding. Imagine a presence lurking in the shadows, a gravitational force that leaves no observable trace but still influences the entire cluster. This idea taps into a primal fear of the unknown, where something significant exists but remains unfathomable. The thought of a black hole slipping away into the cosmic void ignites fears of lost knowledge and an unpredictable universe. Furthermore, the implications stretch beyond just one galaxy. The universe is full of unknowns, and this missing black hole serves as a reminder of how much we still have to learn. It suggests that even in our deepest explorations, there may be aspects of the universe that remain hidden, eluding our grasp like phantoms in the night. This unsettling prospect becomes a narrative of cosmic horror, inviting us to ponder our place in the vast and mysterious cosmos. As we look to the stars, the question lingers: are we truly alone in our understanding, or are there unseen forces lurking just beyond the reach of our comprehension? The concept of a black hole introduces a profound sense of instability into our understanding of the universe. Black holes are regions in space where gravity pulls so intensely that nothing, not even light, can escape. This powerful force fundamentally challenges our ideas about control and order in the cosmos. In a universe where black holes exist, the traditional hierarchy we often assign to celestial bodies, where stars and planets seem to dominate the scene, is disrupted. A black hole acts as a wild card, altering the balance of power. It can consume entire stars, reshape galaxies, and create chaotic environments where normal rules no longer apply. Imagine a predator in the cosmic realm, lurking in the shadows, capable of swallowing vast amounts of material and essentially rewriting the narrative of the surrounding space. This unpredictability instills a sense of fear. When something as seemingly stable as matter is so easily transformed by the immense gravity of a black hole, it showcases how fragile the structures in the universe really are. The cosmic order, which humans often perceive as fixed and reliable, can be upended in an instant. It also raises questions about our own place within this framework. If the universe can be altered by such enigmatic forces, what does that say about our understanding of power and existence? As researchers strive to understand these enigmatic features of the universe, it becomes clear that the narrative is one of continuous change, complexity, and deep mystery. Black holes serve as reminders that amidst the vast beauty of the cosmos lies a chaotic power that we are still coming to terms with, a force that can both inspire awe and evoke terror as we seek to grasp our place in this ever-shifting universe. As we look deeper into the cosmos, particularly toward areas shrouded in mystery or hardship, our future observations could unveil stark realities that reshape our understanding of the universe. Take, for instance, areas where massive star systems are in their final stages, or regions where black holes consume everything around them. Observations in such environments may reveal a harsh cycle of destruction that challenges the notion of cosmic balance. By employing advanced telescopes and technologies, scientists may discover signals or phenomena indicating that star formation is not as prevalent as once thought. This could point to systemic issues in the life cycle of galaxies, suggesting that instead of being vibrant and ever-evolving, many might be in decline, experiencing a slow fade into darkness. Such a finding would challenge the optimistic view of the universe as a well-balanced system nurturing new stars and planets. Additionally, as we study the remnants of supernovae, we may uncover more about the explosive deaths of stars and the role they play in recycling elements throughout the cosmos. A clearer understanding of these events might lead to grim realizations about the fragility of life in the universe, emphasizing that only a small fraction of stars develop planets capable of sustaining life. Moreover, exploring areas densely populated with dark matter may reveal how this unseen substance influences the formation of structures in the universe. We might find that the gravitational forces of dark matter create environments hostile to life, leading to a more complex narrative about where life might emerge. As our gaze extends farther into the universe, we could confront unsettling truths about the balance of creation and destruction. These observations may shift our perception, reminding us that the cosmos is not solely a place of beauty and birth, but also of chaos and decline, painting a more nuanced picture that reflects the realities of existence beyond our planet. The Socinus Galaxy X1 is a remarkable object, known primarily for the extreme radiation it emits. This galaxy, located several million light-years away, hosts a unique supermassive black hole that actively feeds on surrounding material. As this gas and dust swirl into the black hole, they heat up to staggering temperatures, generating intense radiation across various wavelengths, including X-rays and gamma rays. Within this environment, the extreme radiation creates a region that can only be described as a nightmarish zone. The intensity of the radiation is harmful and can disrupt the formation of new stars. Instead of allowing the usual dance of stellar birth to flourish, the radiation effectively sterilizes large parts of the galaxy, preventing gas clouds from coalescing into new stars. These rays impact any matter they encounter, stripping away layers of gas and leading to the ionization of atoms, which can radically alter chemical processes. Moreover, this radiation can produce winds of particles that blow out into space, further dispersing the materials needed for star formation. This means that, in an area where stars would typically grow and evolve, we find a turbulent expanse filled with hazardous energy. Life, as we know it, would stand no chance in such a harsh, radiation-saturated environment. Thus, the extreme conditions created by Socinus Galaxy X1 form a zone where the basic processes of the universe are disturbed, rendering it inhospitable and preventing the vibrant, starry landscapes that might otherwise arise. This stark contrast enhances our understanding of how phenomena like supermassive black holes can shape their surroundings in profound and unsettling ways. Socinus X1 is a fascinating object in our universe, known for being a binary star system that includes a black hole. The gravitational pull generated by this black hole is incredibly strong and affects everything around it, particularly nearby stars and any planetary bodies that might exist in its vicinity. When we think about gravity, it's the force that pulls objects toward one another. In the case of Socinus X1, the black hole exerts a pull that is significantly stronger than that of ordinary stars due to its dense core. This means that stars close to it could be drawn toward the black hole, potentially spiraling in over time. As they approach, they may experience extreme gravitational effects, causing them to distort and change shape. Some might even be torn apart and consumed by the black hole, leading to a spectacular release of energy. For any planets orbiting stars near Socinus X1, the situation is equally precarious. If a planet finds itself too close to this powerful gravitational force, it may be unable to maintain a stable orbit. Instead, the planet could be flung into different trajectories, possibly leading to collisions with other celestial bodies or being ejected from its original star system altogether. The intense gravitational pull can also create radiation and high-energy particles that can be harmful to any potential life forms, making survival unlikely in such an environment. Thus, the gravitational influence of Socinus X1's black hole not only reshapes the fate of nearby stars, but also alters the very nature of any worlds that might exist in its shadow. The chaos and beauty of this cosmic interaction remind us of the dynamic and sometimes violent nature of our universe. In the realm of astrophysics, certain black hole systems can serve as exceptional natural laboratories for understanding extreme physics. One such system is a binary black hole configuration, where two black holes orbit each other. This interaction creates a dynamic environment that produces immense energy, revealing fascinating insights into the laws of physics. As these black holes spin and interact, they generate gravitational waves, ripples in space and time. When two black holes merge, the energy released is equivalent to the energy produced by millions of supernovae, creating strong vibrations that can be detected far across the universe. These gravitational waves give scientists a way to study the properties of black holes, including their masses, spins, and the nature of their formation. Additionally, the area around a black hole is known for its extreme conditions, with intense gravitational forces and strong magnetic fields. When matter falls into a black hole, it forms an accretion disk, a swirling mass of gas and dust that heats up to staggering temperatures. This process emits high-energy radiation, including X-rays and gamma rays, making these systems some of the brightest sources in the universe. By observing this radiation, astrophysicists can glean information about the behavior of matter under extreme conditions. Moreover, these systems challenge our understanding of fundamental physics, particularly how gravity interacts with other forces. The extreme environments can lead to phenomena such as time dilation and matter behaving in ways that deviate from our typical experiences. This intersection of gravity and quantum mechanics raises questions about the very fabric of our universe. Black hole systems act as natural laboratories of terror, unveiling the extreme behaviors of matter and energy that defy our regular observations, fueling curiosity and advancing our understanding of high-energy astrophysics. By studying these celestial giants, scientists can uncover new physics and refine existing theories, bringing us closer to understanding the universe's greatest mysteries. The black hole at the center of NGC 4889 is an extraordinary giant, remarkable in its size when we consider the vast array of black holes scattered throughout the universe. Imagine the range of black holes, from small ones with masses a few times greater than our Sun, to supermassive ones, which reside at the heart of galaxies and can have masses millions or even billions of times that of our Sun. Now, NGC 4889's black hole stands out distinctly among these titans. It is one of the largest black holes known, boasting a mass estimated to be around 24 billion times greater than that of our Sun. To visualize this, consider connecting this black hole to something familiar, a soccer ball representing our Sun. Comparing the sizes, the NGC 4889 black hole would be like a massive mountain looming over it. The sheer scale of this black hole pushes the boundaries of our understanding and challenges our theories about how such massive objects can form. In a universe where other supermassive black holes are already awe-inspiring, NGC 4889 stands as a reminder of the incredible diversity of cosmic structures and the mysteries that still linger about their formation and evolution. The existence of such an enormous black hole invites questions about the dynamics of galaxies and the nature of matter and energy surrounding it, keeping scientists fascinated and eager to explore further. In the vast tapestry of the universe, black holes are among the most enigmatic and formidable entities. These cosmic giants appear dormant, yet they hold an ever-present threat due to their immense gravitational influence. The key to understanding their behavior lies in their life cycle and interaction with surrounding matter. A black hole becomes dormant when it stops actively consuming nearby gas and stars. Imagine a vacuum cleaner that for a time sits quietly, only to spring to life when it encounters dirt. Similarly, a black hole waits patiently, absorbing material when it comes close. However, during periods when it attracts little to no matter, it remains undetectable, quiet yet perilous, lurking in the shadows of space. Their ability to maintain this dormant state for eons stems from the infinite vastness of space. With stars and gas distributed unevenly throughout the universe, a black hole may go long stretches without encountering anything to devour. This absence of activity doesn't diminish its power. Rather, it exists in a delicate equilibrium, ready to awaken at any moment. Moreover, black holes can affect their surroundings over immense timescales. The warping of space around a black hole generates strong gravitational forces capable of influencing the orbits of nearby stars. Even without actively consuming anything, these gravitational pulls ensure that black holes remain significant players in their cosmic neighborhoods, guiding the motion of celestial bodies while cloaked in mystery. Over cosmic history, black holes have outlasted many celestial events. Their sheer density ensures that they withstand the extraordinary pressures of explosive stellar deaths or the violent collisions of galaxies. Each interaction with the universe adds layers to their already complex nature, making them timeless guardians of cosmic balance. Ultimately, a dormant black hole embodies the haunting idea that danger can accompany silence. While it may seem at rest, its potential for destruction lingers, reminding us of the intricate and dynamic relationships that define the universe. The vast stretches of time in which they remain hidden are not a sign of weakness, but rather a testament to the intricate and often invisible dance of cosmic forces. NGC 4889 is a giant galaxy that holds an immense supermassive black hole at its center, one of the largest known in the universe. This black hole, while invisible, exerts a gravitational influence that shapes the entire galaxy. The presence of such a massive object can go unnoticed for incredibly long periods, making it a silent threat to its surroundings. Imagine a predator that carefully hides in plain sight, its effects felt but rarely seen. The black hole in NGC 4889 is a prime example of this. It doesn't emit light like stars do. Instead, it pulls in nearby stars and gas without revealing itself until it devours something, which can lead to flashes of energy. But these are brief moments in the vast galactic timescale. For many billions of years, it may simply exist, quietly affecting the orbits of stars around it and influencing the structure of the galaxy without drawing attention. The sheer mass of the black hole results in significant gravitational pull. This can disrupt the orbits of stars in its vicinity, potentially sending them into deeper regions of the galaxy, or even pulling them toward the black hole's maw, where they would eventually be consumed. Such processes can take millions of years, emphasizing how black holes can operate unnoticed over lengthy periods, posing a continuous threat to the stability of their environments. Furthermore, the slow growth of supermassive black holes often occurs through the accumulation of matter from surrounding regions. Many stars can spiral inward, drawn closer and closer over time, slowly feeding the black hole. This process can be so gradual that it happens entirely under the radar, making it difficult for observers to notice the changes until significant cosmic events, like the sudden explosion of a star near the black hole, reveal what's happening. In a galaxy context, NGC 4889 embodies how supermassive black holes can be both powerful and elusive. While galaxies around them may evolve and change, the central black hole quietly lurks, its ability to consume matter and alter galactic dynamics a constant unseen threat over eons. The Phoenix Cluster is home to a supermassive black hole that exerts extraordinary energy. This black hole doesn't just sit quietly, it actively influences its surroundings, emitting energy levels that are staggering by our standards. One of the most striking aspects of this black hole's behavior is its jets, powerful streams of particles shot out at incredible speeds from the regions near the black hole. These jets can deliver energy that is millions of times greater than that of our Sun, making their presence felt across vast distances in space. As the black hole pulls in gas and dust from the cluster, this material heats up tremendously, reaching temperatures intense enough to create an abundance of X-rays. These high-energy X-ray emissions are vital clues for astronomers, hinting at the ferocity of the black hole's appetite. The energy from these X-rays can be detected by space telescopes, revealing the remarkable dynamics of the black hole's influence on its environment. Additionally, the intense gravitational forces present create ripples in space-time itself, impacting everything around the black hole. This gravitational pull shapes galaxies and clusters, illustrating how interconnected these colossal entities are. The energy outputs in the Phoenix Cluster exemplify the black hole's formidable presence, demonstrating that even in the depths of space, energy can manifest in ways that dwarf our Earth's capabilities. Black holes play a central and often fearsome role in their galaxy clusters, and their effects can be felt on a grand scale. Imagine a massive black hole at the heart of a galaxy, its pull so strong that it oversees the motion of stars and gas in its surroundings. This influence extends beyond just the local neighborhood. It reaches out to the entire cluster of galaxies, shaping their structure and interaction. As a black hole consumes surrounding material, it releases energy in the form of powerful jets, influencing the gas within the galaxy cluster. This energy can heat the surrounding gas, preventing it from cooling and forming new stars. A black hole can stifle the birth of stars, impacting the entire evolution of the cluster. This phenomenon demonstrates how a singular entity can wield immense power over a larger cosmic community. Moreover, the gravitational pull of a black hole affects the orbits of stars throughout the cluster. It dictates how stars move and interact with one another, creating an intricate dance governed by the black hole's dominance. As galaxies collide and merge, the black hole's influence can intensify, sometimes prompting the mergers of smaller black holes into a larger one, highlighting its growing strength. In this way, black holes not only dictate the fate of their host galaxies, but also establish a terrifying hierarchy within galaxy clusters. Their unseen presence asserts a gravitational authority that can shape the very fabric of cosmic existence. illustrating the overarching and unsettling power they possess across the universe. When we talk about radio emissions from cosmic entities, we are often referring to the vast explosions of energy that can originate from sources such as pulsars, quasars, and particularly powerful galaxies. These radio emissions are like ripples in the fabric of space, traversing the intergalactic medium, which is the relatively empty space between galaxies filled with gas, dust, and energetic particles. One of the chilling effects of these emissions is the way they interact with the extremely thin gas that exists throughout the universe. As radio waves travel through this medium, they can heat the gas particles, resulting in changes that affect the temperature and electromagnetic properties of this intergalactic material. A slight increase in temperature might not seem significant, but when you consider that the intergalactic medium is already at very frigid conditions, even a small change can influence the dynamics of gas flows and star formation across vast distances. Additionally, these radio emissions contribute to what scientists describe as cosmic microwave background radiation and can influence the ionization levels of nearby matter. This interaction can create areas where the density is altered, potentially affecting the formation and evolution of galaxies themselves, as these regions may become more or less conducive to the birth of new stars. These radio waves also carry energy that can ionize neutral hydrogen and other elements in space, leading to the formation of ionized plasma. This plasma can, in turn, interact with magnetic fields, creating complex structures that can stretch across light years. Through this process, radio emissions cast long shadows, revealing that even in the vast emptiness of space, the remnants of energetic cosmic events are woven into a complex tapestry of interactions, influencing everything from the very composition of the intergalactic medium to the future of galaxies millions of light years away. Cygnus X1 began as an enigma, one of many points of light detected in the sky producing X-rays. These high-energy rays suggested the presence of an extraordinary object, but it took time for scientists to fully understand its nature. In the early 1960s, astronomers noted this bright X-ray source was located in the constellation Cygnus, and they realized that it was not merely a random event in the cosmos. The turning point came with the recognition that Cygnus X1 was part of a binary system, two stars locked in a dance around each other. One of these stars was a blue supergiant, a massive star on the brink of its explosive demise. The other, which we later identified as being at the heart of the X-ray emissions, was invisible. Its unseen partner was drawing matter from the supergiant star, creating a swirling disk of gas as it fed. As scientists studied the motion of the visible star and the unseen companion, they discovered that the gravitational forces involved hinted at a mass far greater than that of a normal star. They calculated that this invisible object must be extremely dense, so dense, in fact, that nothing could escape its pull, not even light. This led scientists to the conclusion that it was likely a black hole. The combination of precise measurements, theoretical models, and observations of the intense X-ray emissions allowed the scientific community to transform Cygnus X1 from a simple point of light into the first strong black hole candidate. Its story became legendary because it offered astronomers a glimpse into the extreme conditions surrounding black holes, igniting further research into these mysterious regions of space. What started as an unidentified X-ray source became a benchmark for understanding black holes, influencing both academic inquiry and popular culture. Cygnus X1 not only reshaped perceptions of black holes, but also solidified its place in the fabric of astrophysics, transforming our understanding of the universe's most captivating phenomena. The Cygnus X1 system presents a striking example of the powerful forces of nature, inviting deep existential reflections. At the heart of this system is a black hole, exerting an immense gravitational pull, which can be both awe-inspiring and terrifying. Witnessing such intense gravitational effects can evoke fears related to our place in the universe and the limits of human understanding. When considering a black hole's influence, one is reminded of the vulnerability of life itself. It raises questions about the fragility of existence. Imagine looking at the edges of a black hole, where light itself struggles to escape. This might prompt thoughts about how small and insignificant we are in the grand scheme of the cosmos, emphasizing the vastness of unattainable knowledge. Moreover, the concept of time behaves oddly around black holes, adding layers to our fears. Time can slow down dramatically near such a massive object. Observers far away may witness events unfolding quickly, while those close to the black hole experience a different reality. This disparity makes one ponder the nature of reality itself and the uncertainty of our future. The idea of being drawn into a black hole also speaks to existential dread. It symbolizes the ultimate end, a point of no return where all that we are and know could be swallowed into obscurity. Such a scenario encourages reflections on mortality and the limits of human achievement, stirring a sense of urgency to explore while we still can. Additionally, witnessing the complex interactions within the Cygnus X1 system can inspire awe and fear over the unpredictability of cosmic events. It reinforces the understanding that the universe is full of mysteries and that many phenomena remain beyond human control. This sense of unpredictability can provoke existential anxiety, as it highlights our inability to fully comprehend the forces that govern everything around us. Witnessing the gravitational dynamics of the Cygnus X1 system brings forth a multifaceted mix of fear and curiosity, prompting deep introspection about existence, the nature of reality, and our role within the vast tapestry of the universe. Cygnus X1 is a fascinating celestial object that has intrigued scientists for decades, primarily because of its unique interplay between light and shadow. At its core, Cygnus X1 is an intense source of X-rays, which reveals its violent nature as it partakes in a dramatic dance with its companion star. In this system, the black hole, which is invisible, exerts a strong gravitational pull on the nearby star, drawing in material from it. This material spirals into the black hole in a process known as accretion, forming a bright disk of hot gas around it. As this gas heats up, it emits X-rays, which are detected by our telescopes. This is the light in this interplay. It signals the activity occurring just outside the grasp of the black hole. The bright light from the accretion disk contrasts sharply with the darkness of the black hole itself, which absorbs all light and is invisible to us. This stark contrast of light and shadow creates a captivating image of destruction and creation. Moreover, the more scientists study Cygnus X1, the more they discover about its behavior and characteristics. For example, by observing changes in the brightness of the X-ray emissions, researchers can infer the activity level of the black hole and the rate at which it consumes its companion star. These dynamic changes help scientists understand the complex physics involved in such extreme environments, illuminating theories about how black holes influence their surroundings. Additionally, Cygnus X1 holds a special place in the history of astronomy, having been one of the first strong black hole candidates identified. This historical context adds another layer to its appeal. Researchers are continually revisiting this object not only for its current phenomena, but also to appreciate how far our understanding of the universe has developed over the years. As technology advances, so too does our ability to observe and explore the intricate details of systems like Cygnus X1, ensuring it remains a captivating focus for scientists eager to unravel the mysteries of the cosmos. Gravitational lensing is a fascinating phenomenon that occurs when massive objects like black holes warp the fabric of space around them. In the case of Max J 1149 plus 2223, this cluster of galaxies contains a supermassive black hole that bends the light from objects behind it. Imagine placing a large, heavy ball on a stretched-out fabric. The ball creates a dip, which affects the path of nearby objects, causing them to curve around the dip instead of following a straight line. As astronomers study how this distortion affects the light of distant galaxies that lie behind the black hole, they can gather clues about what lies hidden within. The light from these distant galaxies becomes magnified and stretched into arcs around the black hole, allowing scientists to see objects that would otherwise be too faint or far away to detect. This lensing effect not only provides valuable information about the distribution of mass in the galaxy cluster, but also reveals the unseen horrors of the black hole itself. By analyzing the way light is bent, scientists can infer details about the black hole's mass and its gravitational pull, which are crucial for understanding its nature. The more mass a black hole has, the stronger its gravitational influence, and this can lead to extreme environments around it. These regions can be sites of powerful radiation and incredible dynamics, which hint at the chaotic processes occurring just outside its event horizon. Thus, the lensing effect in Max J 1149 plus 2223 doesn't just visually illustrate the black hole's presence. It unveils the harsh realities of the cosmic forces at work, showing how they interact with light and matter in profound ways, offering a glimpse into the mysteries that swirl around these enigmatic giants lurking in the universe. The discovery of black holes, particularly those formed in the very early universe, offers profound insights into how the cosmos evolved. These ancient black holes act like time capsules, preserving information about conditions just moments after the Big Bang. By studying them, scientists can understand how galaxies and large-scale structures began to form. The growth patterns of these black holes hint at how matter began to cluster, revealing much about the mysterious dark matter that influences the entire universe. This knowledge challenges our previous perceptions of cosmic terror. Traditionally, black holes were seen primarily as catastrophic entities, consuming everything in their vicinity. However, through these ancient black holes, we begin to see them in a new light, less as reckless predators and more as architects of the universe. This duality redefines our understanding of fear in the cosmos. The terror doesn't merely stem from their destructive power, it also grows from our awe at their complexity and their capacity for shaping the very fabric of existence. With this insight, we realize that black holes are fundamental to the creation of our universe, making them not just objects of fear, but also of fascination and importance. Future discoveries about black holes could profoundly reshape our understanding of space in several ways. Imagine each black hole as a gateway to understanding the fundamental laws of the universe. These immense structures not only pull in matter with their powerful gravity, but they also challenge our existing theories about how the cosmos works. As scientists gather more data, particularly from advanced telescopes and space missions, they might uncover new characteristics of black holes. For example, by observing how stars behave around these cosmic giants, researchers can learn about the conditions of extreme gravity. This can reveal clues about the nature of space-time itself, the very fabric that makes up the universe. Moreover, if we find black holes interacting in unexpected ways, it could lead to insights about the relationship between gravity and other fundamental forces, like electromagnetism. These connections could potentially provide answers to questions about how the universe began and how it may end. Black holes might also hold keys to understanding dark matter and dark energy, mysterious components that are thought to make up much of the universe yet remain largely unexplained. By studying the effects of black holes on surrounding matter, scientists might unlock the secrets of these elusive forces. Each new discovery about black holes broadens our horizons, deepening our grasp of cosmic phenomena and expanding the boundaries of human knowledge. The more we learn, the closer we get to deciphering the mysteries of the universe, revealing not just how it functions, but potentially why it exists in the first place. The black hole thought to be hiding in the dwarf galaxy, Leo 1 is cloaked in an intriguing veil of uncertainty. Dwarf galaxies like Leo 1 are smaller, dimmer, and less massive than larger galaxies, making them challenging to study. This particular galaxy, located a significant distance from Earth, shows signs of a black hole at its center, yet proving its existence remains elusive. What adds to the mystery is the black hole's size. If it exists, it may not be as massive as those found in larger galaxies. Instead, it could be more similar to the smaller types of black holes formed from the collapse of massive stars. Researchers are trying to understand how such a black hole could have developed in a galaxy with so few stars. To grasp the potential presence of this enigmatic black hole, astronomers look for gravitational effects on nearby stars. The way stars move and their speeds can indicate how much mass is concentrated in the center. However, Leo's faint nature complicates these measurements. Scientists are now utilizing advanced observational tools to probe deeper into the galaxy, seeking this hidden giant. As research progresses, the mystery surrounding the black hole could unravel. Its discovery would not only reshape our understanding of black holes themselves, but also hint at the dynamics of dwarf galaxies and the role they play in the broader cosmic environment. The unknown qualities of the black hole in Leo 1 represent an exciting frontier in astrophysics, where each new finding brings us closer to understanding these extraordinary features of the universe. The existence of a supermassive black hole within a dwarf galaxy can dramatically change our understanding of the cosmos and the nature of galaxies themselves. Dwarf galaxies are typically small, containing fewer stars compared to their larger counterparts. The discovery of a massive black hole in one of these seemingly simple structures challenges the conventional perspective that larger galaxies are the exclusive hosts of such powerful entities. Imagine a tiny town discovering a giant skyscraper suddenly appearing in its midst. This analogy reflects how a dwarf galaxy, which is expected to be quiet and relatively stable, now houses a black hole capable of exerting enormous gravitational forces. This revelation prompts scientists to rethink what governs galactic formation and evolution. It raises questions about the history of matter in the universe, suggesting that even small galaxies can carry the remnants of explosive cosmic events. Furthermore, this newfound understanding encourages researchers to explore how these black holes interact with their surroundings. How could a black hole influence star formation, or how do it affect the galaxy's overall dynamics? The presence of such an intimidating entity might also hint at a more interconnected universe, where the mechanics of gravity and evolution are not as localized as previously thought. This paradigm shift invites us to consider the complexity and diversity of the universe, urging a re-evaluation of what we believe about galactic structures and the role of black holes in the grand tapestry of existence. The implications extend beyond just one galaxy. They influence how we perceive the behavior of galaxies throughout the universe, pushing our boundaries of understanding further than ever before. The black hole, known as Leo 1, hides fascinating clues that could lead us to uncover the universe's hidden mysteries. One of the most compelling aspects of this black hole is its location within a dwarf galaxy. Dwarf galaxies like Leo thus often contain less visible matter than larger galaxies, making the gravitational effects of black holes more pronounced. By studying Leo 1, scientists can gather insights into how black holes interact with their environment, particularly how they influence the formation and evolution of stars within these smaller galactic structures. Moreover, Leo 1's black hole may provide clues about the distribution of dark matter, that unseen substance that makes up a significant portion of the universe's mass. The behavior of stars in the vicinity of the black hole can reveal how dark matter is spread throughout the galaxy. Observing the orbits of these stars allows researchers to infer the presence and effects of this elusive substance, creating a clearer picture of its role in galaxy formation. There is also the possibility that examining Leo I can enhance our understanding of gravitational waves. When two black holes merge, they produce ripples in space-time known as gravitational waves. If Leo 1's black hole interacts with others in its region, studying these phenomena could open new pathways in our grasp of cosmic events and the fundamental laws of physics. Finally, looking deeper into the characteristics of Leo 1's black hole can help us explore the very nature of black holes themselves. Discovering variations in size, rotation, or energy output could challenge existing theories and encourage scientists to rethink the formation and growth processes of black holes across the universe. Leo Y serves as a portal to understanding not just one black hole, but the broader forces and materials that govern our universe, shedding light on its most profound secrets. The black hole at the center of Messier 87 serves as a fascinating case study, challenging our understanding of how supermassive black holes evolve and interact with their surroundings. This particular black hole is incredibly massive, billions of times the mass of our Sun, and it has an unprecedented amount of gravitational pull. This immense force shapes the environment around it in ways that defy simple explanations. Historically, scientists believed that supermassive black holes primarily grew by pulling in surrounding gas and dust, steadily increasing in size over time. However, observations of Messier 87 reveal that its black hole also plays a dynamic role in the galaxy's development. For instance, the extraordinary jets of energy and matter that erupt from this black hole stretch far into space. These jets not only push back against the surrounding material, but can also influence star formation in the galaxy. This leads to a unique transformation process. Rather than simply accumulating mass continuously, The black hole actively reshapes its environment, potentially stunting the growth of nearby stars and galaxies. It creates an interconnected cycle of feeding and influencing, a kind of cosmic tug-of-war that alters how we see the relationships among black holes and their galaxies. Additionally, examining the image captured by the Event Horizon Telescope has provided researchers with insights into the behavior of matter as it spirals into the black hole. This dramatic infall can change the black hole's characteristics, leading to hypotheses about the mechanisms behind growth, feedings, and shifts in energy states. This challenges our traditional perceptions, suggesting that supermassive black holes are not just passive entities minutely feeding over time. Instead, they actively engage with their cosmic neighborhoods, transforming their host galaxies in profound and complex ways. The study of Messier 87 prompts questions that stretch beyond the black hole itself, inviting us to explore the broader implications of black hole behavior in our universe. Messier 87 is a giant galaxy located about 53 million light-years from Earth, and it is home to one of the most mysterious and powerful phenomena in the universe, a supermassive black hole. This black hole, at the center of Messier 87, is surrounded by swirling material heated to extreme temperatures. This intense energy creates a bright, glowing disk known as an accretion disk. The characteristics of this black hole truly offer a sinister perspective. As matter spirals into the black hole, it accelerates and produces immense heat and light, making this region one of the brightest spots in the galaxy. The energy emitted from this chaotic process is so strong that it can outshine all the stars within the galaxy combined. Beyond the accretion disk, there are powerful jets of particles that are expelled at nearly the speed of light, shooting far into the surrounding space. These jets, formed by magnetic fields interacting with the hot gas, can stretch over thousands of light-years and may even affect galaxies far beyond Messier 87. The very nature of a black hole itself suggests a sinister reality, where the gravitational pull is so strong that nothing can escape once it crosses a certain point. This creates an environment where time and space behave differently. Close to a black hole, the universe operates under extreme energy conditions, distorting our understanding of physics. Such phenomena highlight the paradox of creation and destruction, as the immense energy released can illuminate but also annihilate matter. Thus, Messier 87 encapsulates a striking yet eerie wonder of the universe, blending immense energy with a sense of danger, revealing the powerful forces that govern the cosmos in unsettling ways. The image of a black hole profoundly shapes how we view the universe and our place within it. It serves as a powerful reminder of the mysteries lurking in the cosmos. This intense gravitational force, which swallows everything in its vicinity, challenges our understanding of physics and reality itself. When we first glimpsed the image of a black hole, it was like seeing a shadow of something that defies the laws of nature as we know them. This sight forces us to grapple with fundamental questions about existence. It evokes a sense of awe and fear, illustrating the limits of human knowledge. Scientists and explorers of the universe contemplate the role of black holes in the life cycle of stars and the fabric of galaxies. They are not just cosmic oddities, they are pivotal players in the grand ballet of the cosmos, influencing the behavior of light and matter around them. Moreover, the idea that there are regions in the universe where the known laws of physics fail ignites our imagination. This intrigues not only scientists but also artists, philosophers, and thinkers, imbuing our perception of the universe with an alluring mystery. The black hole serves as a symbol of the unknown, nudging us to question what lies beyond our current understanding and inspiring future generations to explore the vastness of space. Such an image acts as a catalyst, compelling humanity to seek answers to questions about gravity, time, and even the nature of reality itself. The black hole in NGC 4395 is a fascinating case that challenges what we traditionally think about the centers of galaxies. For many years, the belief was that supermassive black holes, which are incredibly large and dense regions in the heart of galaxies, must have bright and lively surroundings filled with infalling gas and stars. These glowing accretion disks create a spectacular sight that indicates strong gravitational forces at work. However, NGC 4395 offers a different narrative. This black hole is surprisingly less luminous, almost quiet. Imagine visiting a busy city center where every street is filled with lights and activity, and then discovering a contrasting calm neighborhood tucked away where few signs of life exist. That's akin to what astronomers see in NGC 4395. The quiet nature of its black hole suggests that it doesn't pull in material at a rapid rate, resulting in a much dimmer appearance compared to other black holes. This observation raises important questions about the nature of black holes and their environments. It reveals that some black holes can exist in a more subdued state, possibly implying that the energetic activities often associated with black holes might not be necessary for their existence or for them to influence their galaxy. The subtle presence of the black hole in NGC 4395 reminds us that there are aspects of the universe that do not fit perfectly into our expectations, allowing us to consider a broader range of possibilities regarding how galaxies and their centers develop over cosmic time. The existence of a small black hole, despite its compact size, can reveal a lot about its potential dangers. Imagine black holes as cosmic vacuum cleaners. Even a black hole that is relatively tiny can possess an incredibly strong gravitational pull. This means that anything nearby could be drawn in without much warning. The more active a black hole is, the more material it is consuming around it, creating an environment that's exceptionally energetic. When matter spirals into a black hole, it heats up and emits intense radiation, making it a beacon in the dark universe. This activity signals that even a small black hole can influence its surroundings in dramatic ways. Additionally, the minimal size of such a black hole could mean it has remained undetected for a long time. Its concealed nature raises concern because it might be lurking close to other celestial objects, potentially disrupting their orbits or affecting them gravitationally. Thus, without a clear warning, it could suddenly pose a grave threat by altering the trajectories of nearby stars or planets, as if a hidden predator were waiting to pounce. Overall, the combination of size and activity illustrates that even a less imposing black hole can harbor significant threats, creating ripples across the cosmos that we are only beginning to understand. NGC 4395 is a fascinating spiral galaxy that lies about 14 million light-years away from Earth. It stands out in the cosmic landscape, especially because it harbors a surprisingly small black hole at its center. Ongoing studies of this galaxy are revealing layers of complexity that touch on some of humanity's deeper fears and curiosities about the universe. At the heart of NGC 4395, the black hole challenges conventional ideas about these mysterious objects. It acts as a gateway to understanding how black holes influence their surroundings and, in turn, how those dynamics affect galaxies. This connects to our fear of the unknown. Black holes represent the ultimate enigma in the cosmos, where gravitational forces are so strong that even light cannot escape. Learning more about their behavior can help us make sense of the unsettling reality that such entities exist, lurking in the vast darkness of space. Furthermore, studying the interactions occurring around the black hole and the galaxy provides insight into cosmic events that could, hypothetically, impact our own universe. For instance, as matter falls into the black hole, it heats up, emitting radiation that can be studied from great distances. The processes involved in this act could be reminiscent of cataclysmic events we fear might one day affect us, showing how cosmic phenomena have real implications for our understanding of existence and mortality. The star formation in NGC 4395 offers another layer of intrigue. The dynamics between the black hole and the galaxy's gas and dust clouds inform us about how galaxies evolve and transform over time. This raises the question of our place within this ever-changing universe, an acknowledgement of our own fragility amid the colossal forces at work in space. Consequently, research into NGC 4395 serves as both a scientific pursuit and a journey into our psyche. As we scrutinize the fundamental aspects of the universe, we confront our own fears about the unknown and the forces that govern our reality. The inquiries into this galaxy don't merely expand our knowledge, they challenge us to reflect on our vulnerabilities and inspire awe at the enormity of cosmos, revealing how exploration can transform fear into understanding. The black hole at the center of NGC 1365, a spiral galaxy, reveals its intense nature through the light and energy emitted by material falling into it. While black holes themselves cannot be seen because they do not emit light, they impact their surroundings in dramatic ways. As gas, dust, and other stellar material approach the black hole, they spiral inward, forming a disk known as an accretion disk. In this disk, particles rub against one another, generating friction that heats them to extremely high temperatures. As they heat up, they emit bright light, often seen in the form of X-rays, radio waves, and even visible light. This energetic glow can pierce through the surrounding darkness of space, making it possible for astronomers to detect the black hole indirectly. Moreover, the black hole's immense gravitational pull can influence stars and gas clouds nearby. These interactions can cause stars to accelerate and emit powerful bursts of energy. Observing these high-energy emissions provides additional evidence of the black hole's presence and intensity. Researchers use sophisticated telescopes equipped to detect various wavelengths of light to capture the dynamic ballet of materials in the vicinity of the black hole, making the unseen energy source seemingly visible. Thus, even though black holes themselves are dark, the radiant activity of the surrounding material unveils their intense nature and reveals the dramatic processes taking place in these extraordinary cosmic phenomena. A rapidly rotating black hole, often called a Kerr black hole, possesses unique features that amplify its enigmatic and terrifying nature. When a black hole spins, it doesn't simply rotate like a planet or a star. Its spin influences the very fabric of space around it. Imagine placing your hand in a pool of water and stirring the fluid. The faster you stir, the more the water swirls, creating whirlpools. In a similar way, the rotation of a black hole causes space itself to twist and bend around it. This twisting effect, known as frame dragging, means that anything entering the black hole's vicinity gets caught in this swirling motion. Objects that stray too close may experience extreme gravitational forces pulling them in. This not only distorts their shape, but also stretches them out, leading to a phenomenon often referred to as spaghettification. The black hole's rotation intensifies these gravitational effects, creating an environment where the rules of physics seem to dramatically change. Moreover, the intense energy at the edges of a rotating black hole allows it to eject high-energy jets of particles. These jets shoot out into space at nearly the speed of light, often visible in distant galaxies. So, while the black hole draws in matter in an insatiable appetite, it also spits out bursts of energy in a fierce and astonishing display. The combination of these elements, the extreme gravitational pull, the frightening distortion of space and time, and the violent ejections, creates a sense of cosmic horror. It turns a black hole from a mere region of darkness into a powerful and chaotic force, making it one of the most mysterious and awe-inspiring objects in the universe. Each aspect of its rapid rotation transforms it into a maelstrom of destruction and intrigue, challenging our understanding of the cosmos. The galaxy NGC 1365 is home to a supermassive black hole, which plays a crucial role in shaping the environment around it. This relationship is quite fascinating. Picture a vast cosmic dance where the black hole is the leading performer, exerting a powerful influence over the stars nearby. As stars orbit the black hole, they move along paths determined by its immense gravity. This force keeps the stars in a delicate balance. The closer a star gets to the black hole, the faster it must travel to avoid being pulled in. This creates a dynamic interaction where the black hole's gravitational pull can accelerate stars to incredibly high speeds. Over time, as stars pass by, they may exchange momentum, similar to how billiard balls interact on a table. But the influence of the black hole goes beyond mere motion. It also affects the overall stability and structure of NGC 1365. The gravitational tides it generates can shape the orbits of countless stars, influencing their life cycles and affecting star formation in the galaxy. Regions of gas and dust near the black hole can become compressed, giving rise to new stars, while others may get torn apart by gravitational forces. This eerie connection illustrates a two-way interaction. Stars not only react to the black hole's pull, their movements and behavior can also affect the black hole itself. When stars move in and out, they contribute to the feeding process of the black hole, providing essential material that can lead to bursts of energy. appearing as bright emissions often observable in different wavelengths. This intricate relationship between the black hole of NGC 1365 and the stars surrounding it is a complex web of influence, where both elements entwine, reflecting the profound ways in which these cosmic structures interact within the grand tapestry of the universe. The binary black hole system of PG 1302, 102 presents a fascinating and somewhat unsettling chapter in the study of the universe. In this system, we have two supermassive black holes that orbit each other at a remarkably brisk pace. Their rapid motion carries profound implications for our understanding of gravity, cosmic evolution, and the nature of black holes themselves. When we observe these black holes moving quickly around one another, it suggests that they are gravitationally bound in a close relationship, much like a dance. This close proximity allows us to study how they influence each other. As they spiral inwards, they release gravitational waves, ripples in space-time that can be detected far from the source. This phenomenon not only confirms the predictions of Einstein's theory of relativity, but also opens up a new window into understanding the dynamics of such monstrous entities. The unnerving part comes from the sheer scale and power of these black holes. They are located at the centers of galaxies, and their interactions might indicate a long-lasting history that could date back billions of years. Such systems can impact their surrounding environments significantly, possibly affecting star formation and the behavior of entire galaxies. Moreover, the rapid motion suggests instability in their orbits, which increases the likelihood of a merger in the future. When two black holes collide, the event releases an enormous amount of energy, eclipsing that of all the stars in the universe for a brief moment. Such cataclysmic events raise questions about the fabric of space-time itself and the potential consequences of energy release on galactic scales. The binary black hole system, PG 1302, 102, serves not only as a critical case study in astrophysics, but as a reminder of the violent and dynamic processes that govern the universe. Its rapid motion beckons us to explore the deeper mysteries of black holes, the evolution of galaxies, and the fundamental laws of physics that underpin everything we see in the cosmos. Astronomers see the merging of black holes as a possible event that could unleash immense energy and revolutionize our understanding of the universe. To visualize this, think of two massive objects in space, each a black hole with a gravitational pull so strong that nothing can escape it. As they orbit around one another, they draw closer, spiraling inward due to their powerful gravity. This process isn't simple. It takes time as they lose energy through gravitational waves, ripples in the fabric of space and time. These waves carry information about their movement, kind of like how sound travels through air. When black holes finally collide, they can merge into a larger black hole, a phenomenon that can release more energy than the entire output of all the stars in a galaxy combined. This potential cataclysm is exciting for astronomers because it could provide insights into the fundamental laws of physics, including how gravity works on extreme scales. Observatories specifically designed to detect gravitational waves have already captured signals from earlier black hole mergers, capturing sound waves created by these cosmic events. Each of these signals helps scientists piece together a clearer picture of how black holes interact and influence the universe. As astronomers continue to study these celestial phenomena, they not only anticipate the merge itself, but also the aftermath, which has the potential to reveal hidden truths about the nature of reality, dark matter, and even the origins of the universe. In that sense, these mergers are more than just cosmic explosions. They represent a window into understanding forces that govern everything around us. The system of PG 1302, 102, known for its extreme and violent interactions, reveals some unsettling insights about the cosmos. At the core of this fascinating structure is a black hole, an invisible force that exerts an overwhelming gravitational pull on nearby matter. As surrounding stars spiral toward the black hole, they often collide, leading to cataclysmic events. These collisions can release tremendous amounts of energy, often in the form of bright bursts of radiation. The horrifying conclusion from these interactions is that such dynamics highlight the chaotic nature of the universe. Stars are not merely isolated entities, but rather play parts in a much larger, often brutal cosmic ballet. The destruction of one star can lead to the creation of new ones, and the expulsion of material that could potentially form new planetary systems, but it can also signify an end, a cessation of life and existence in that region. Moreover, the violent energy expelled during these interactions can have far-reaching effects. Massive jets of radiation can strip away the atmospheres of any nearby planets, making them uninhabitable. This destruction raises alarming questions about the stability of life in the universe. If such catastrophic events are commonplace, how many potential worlds have been snuffed out before they could even begin to develop? Ultimately, PG 1302 102 serves as a stark reminder that while the universe may create beautiful and complex systems, it is also a realm where violence and destruction are inherent. These interactions compel us to ponder our place within this vast and unpredictable expanse, reminding us that life, as we know it, exists amid the ruins of cosmic battles. The neutron star merger known as GW 170817 marked a significant event in the cosmos and provided insights into the creation of black holes. Picture two incredibly dense stars, each made almost entirely of neutrons, spiraling around each other. As they get closer, they start to orbit faster and faster. Eventually, they collide with a cataclysmic force that is nothing short of terrifying. During this merger, enormous amounts of energy are released, creating gravitational waves, ripples in space and time that can be detected by observatories on Earth. This cataclysmic event doesn't just create sound waves in the cosmos, it also blows the stars apart, producing elements heavier than iron like gold and platinum. The explosive aftermath lights up the universe and allows scientists to observe a spectacular event. But what happens to the remnants of these neutron stars? When they collide, the surviving core can become so dense that it collapses under its own gravity, surpassing a critical threshold. This transition transforms the core into a black hole. If the core's mass is significant enough, it can attract surrounding matter, leading to further growth. As the black hole forms, it pulls in any remaining gas and debris, spiraling them into its grasp. Moreover, this merger is significant because it demonstrates a process called kilonova, a brilliant explosion that occurs when the debris produces and ejects heavy elements into space. This massive event contributes to the cosmic cycle of matter, enriching the universe with new elements and illustrating how black holes can emerge in surprisingly dramatic and violent ways. GW 170817 serves as a stunning example of how two neutron stars, with their incredible density and gravitational forces, can give birth to a black hole, expanding our understanding of these mysterious cosmic entities and their formation processes. Gravitational waves are ripples in space-time, produced by some of the most violent and energetic processes in the universe, such as merging black holes or neutron stars. Imagine dropping a stone into a still pond. The waves created radiate outward, but instead of water, these waves travel through the very fabric of the cosmos. When a catastrophic event occurs, like two massive objects colliding, the disturbance not only displaces mass, it sends these ripples racing across the universe. As they propagate, they can stretch and squeeze space itself, creating powerful signals detectable even across vast distances. This phenomenon is one way the universe communicates its most tumultuous events. Gravitational waves are essentially the echoes of these cosmic collisions. These echoes can travel for billions of years, performing a delicate dance around celestial bodies, reaching us long after the original event has passed. When scientists detect these waves, they unveil incredible stories of the universe's history. Each wave carries information about its source, revealing the masses of the colliding objects and the dynamic forces at play during their merger. It's a way to glimpse the terrifying beauty of cosmic events that would otherwise remain hidden, showcasing the relentless and dramatic interactions happening across the vast expanse of space. Thus, gravitational waves are not just disturbances, they are cosmic messengers, telling us about the universe's most awe-inspiring and fearsome moments. Studying cosmic collisions opens up new realms of understanding about the universe and its behavior. These events, which can be extraordinarily violent, reshape our perspective on how celestial bodies interact. When two massive objects, such as galaxies or stars, collide, they don't just pass through each other unscathed. Instead, the gravitational forces at play can lead to spectacular exchanges of energy and momentum. One fascinating outcome of these collisions is the creation of new stars. When clouds of gas and dust collide, they can compress and heat up, leading to conditions ripe for star formation. This means that destruction isn't just an ending, it can also birth new worlds. However, the consequences can be terrifying as well. Collisions can lead to the formation of black holes or trigger violent supernova explosions, massive blasts that occur when certain types of stars exhaust their nuclear fuel and collapse. Furthermore, these studies help scientists understand the larger-scale structure of the universe. For example, observing the aftermath of a collision between two galaxies reveals how clusters of galaxies are formed and how they evolve over time. It provides insight into the distribution of dark matter, which influences the dynamics of galaxies and their interactions. Understanding these phenomena also carries implications for planet formation and potential habitability. The pathway a planet might take through space, influenced by the gravitational tug-of-war during these collisions, could determine if it has the right conditions to support life. By piecing together the consequences of cosmic collisions, we gain a clearer picture of the universe's past, present, and future. It teaches us that chaos can lead to creation and that the universe is constantly evolving in ways we are just beginning to grasp. The millisecond pulsar J1748-2446 AD offers a prime example of the fascinating interactions between neutron stars and black holes. A pulsar is a rapidly spinning neutron star that emits beams of radiation, much like a lighthouse. J1748-2446 AD spins at an incredible speed, completing a rotation dozens of times every second. As it spins, it emits signals that can be detected across vast distances. What sets this pulsar apart is its environment. It resides near a black hole, and their relationship can be quite dramatic. The pulsar's rotating magnetic field can pull in material from its nearby companion star. As this material spirals closer, it forms an accretion disk around the pulsar, creating a high-energy area filled with bright X-ray emissions. However, what makes this system particularly intriguing is how the black hole can exert its influence, silently but ruthlessly. The black hole acts like a predator, silently lurking nearby. While the pulsar radiates energy and grabs attention, the black hole's presence is often felt more than it is seen. It may be quietly feeding on material that is drawn to it, and this process can create gravitational dynamics that dramatically affect the pulsar's behavior. The pulsar continues to emit its regular pulses, but the influence of the black hole changes the environment around it, leading to complex interactions. J1748-2446 AD exemplifies how a seemingly stable source of light and energy can exist alongside a powerful black hole. The pulsar shines brightly, engaging observers, while the black hole's subtle. Its influence shapes the evolving narrative of this cosmic dance, where the pulsar is a vibrant beacon, but also a player in a game of survival against an unseen, formidable force nearby. The pulsar and black hole interact in complex ways. As one entity continues its rapid dance, the other lies in wait, a reminder of the silent threats that exist in the universe. The interaction between a pulsar and its surrounding environment provides valuable insights into how black holes influence cosmic structures. A pulsar is a rapidly spinning neutron star that emits beams of radiation which sweep across space. When a pulsar interacts with nearby material, such as gas and dust from a supernova or interstellar medium, it can create complex patterns of radiation and energy. This interaction hints at how a black hole might similarly affect its surroundings. Black holes possess powerful gravitational forces that can attract surrounding matter, pulling it into a swirling disk and generating intense radiation in the process. This phenomenon helps shape the material around them, influencing star formation and the evolution of galaxies. As a pulsar spins and interacts with its environment, it can create shock waves and compression in nearby gas clouds, ultimately affecting their behavior. This is analogous to how a black hole's gravitational pull can draw in gas and dust, causing it to heat up and emit energy before possibly spiraling into the black hole itself. Thus, the dynamics observed in pulsar interactions suggest that black holes play a significant role in manipulating cosmic structures. They not only shape the material immediately around them, but also have broader implications for galaxy evolution and the large-scale structure of the universe. The study of these interactions helps us understand the powerful forces at play in the cosmos and the delicate balance between creation and destruction orchestrated by these enigmatic objects. J1748-2446 AD is an extraordinary cosmic object, a pulsar located deep in our galaxy, spinning rapidly and emitting beams of radiation. As we uncover more about this pulsar, we might begin to confront unsettling truths about the universe's more mysterious and ominous aspects. This pulsar is particularly fascinating because it lies at the center of a dense cluster of stars where extreme gravitational forces create a harsh environment. Future discoveries about J1748-2446 AD could reveal insights into the nature of immense gravitational forces. These forces can warp space-time and influence surrounding objects in unexpected ways. If researchers find that this pulsar interacts with other dense and exotic matter, it could shed light on the behaviors of matter under extreme conditions, which are often reflected in the more extreme phenomena of black holes and neutron stars, both connected to the darker forces of the cosmos. Moreover, as scientists investigate its rapid rotation, the possibility of detecting gravitational waves arises. These invisible ripples in space-time are produced by the most powerful events in the universe, such as colliding black holes or neutron stars. If a connection can be established between J1748-2446 AD and these cosmic phenomena, it could lead us to a deeper understanding of the chaotic and violent nature of the universe. Finally, as we grasp the behavior of pulsars like J1748-2446 AD, we might also confront questions about the fate of our own star system and the potential dangers that lurk out there. This pulsar's study could highlight the fragile balance of forces in the universe. Each revelation serves as a reminder of the powerful and often unpredictable forces that govern cosmic events and the very nature of reality itself, leaving us pondering our place amid such vast unknowns. Black hole XTEJ 1118+480 has captivated scientists with its fascinating story as it traverses our galaxy. This black hole is part of a binary system, meaning it is paired with a companion star. As it interacts with its partner, it pulls material from the star toward itself, creating a roaring disk of gas and dust that heats up as it spirals inward. This activity generates bright X-rays, making XTEJ 1118+480 one of the most luminous black holes in our vicinity. What makes this black hole particularly striking is its relatively close proximity to Earth, located around 6,000 light-years away. This closeness provides a unique opportunity for astronomers. They can study its behavior and the effects it has on its surrounding environment in ways that are not possible with more distant black holes. Moreover, XTEJ 1118+480's journey through the galaxy reveals the dynamics of black holes moving through regions filled with stars and gas. Observations show that this black hole is moving at high speeds, which suggests that it might have originated in a dense star cluster before being flung out into its current orbit. Such movements provide clues about the violent and chaotic history of star formation and interaction in our galaxy. Additionally, the black hole's behavior can shed light on how it accumulates mass. As it draws in matter, it emphasizes the relationship between black holes and their companion stars. This interaction drives our understanding of stellar evolution and the fate of stars that find themselves in close contact with these gravitational monsters. XTEJ 1118+480 serves as a cosmic laboratory, offering insights into the life cycle of black holes, how they influence their surroundings, and their role in the larger cosmic tapestry as they journey through the vastness of the galaxy. The discovery of a rogue black hole challenges our understanding of safety in the vastness of space. Traditionally, we think of black holes as distant entities, typically residing in the centers of galaxies or in specific stellar systems. However, a rogue black hole is one that has been ejected from its original location and moves freely through the universe. This concept alters our perceptions in significant ways. First, the presence of a rogue black hole suggests that our galaxy is not a bounded haven. Every star and planetary system, including Earth, might find itself vulnerable to encounters with these elusive giants. Though black holes are extremely massive and have strong gravitational pulls, their effects are not felt until one comes dangerously close. Therefore, the dynamics of our galaxy now seem more precarious. Moreover, the sheer unpredictability of rogue black holes adds another layer of complexity. Their origins can vary. Some may result from the aftermath of star collisions or mergers, while others could have formed from primordial conditions in the early universe. This means that, unlike more stationary black holes, which can often be studied and monitored, rogue black holes may not follow predictable paths. They could potentially pass through regions of high density, such as star clusters, creating havoc by disturbing the orbits of nearby stars and possibly leading to a cascade of stellar events. Additionally, the realization that black holes can wander freely across the cosmos forces us to reconsider the sense of cosmic order. Scientists must explore how these rogue entities impact the formation and evolution of galaxies. They could act as cosmic nomads, influencing surrounding environments and potentially feeding on material they encounter, which changes our understanding of stellar interactions and galactic ecosystems. The existence of rogue black holes reshapes our perceptions of safety in the universe, highlighting the complexity and unpredictability of cosmic life, while reminding us that even in the grand scale of galaxies, we are intricately tied to the dance of massive celestial bodies. Astronomers are keenly interested in XTEJ 1118 plus 480 because its unusual behavior offers a window into the complex lives of black holes and their surrounding environments. This particular black hole, located about 6,000 light-years away, is a stellar black hole, meaning it formed from the remnants of a massive star that exhausted its nuclear fuel. The path it follows in the universe is anything but typical, showing erratic movements and sudden bursts of energy. These unpredictable patterns can hint at various cosmic phenomena. The way XTEJ 1118 plus 480 pulls in material from a companion star and emits powerful jets of radiation is creating a lively setting for researchers. By studying these emissions, scientists can learn how black holes interact with nearby stars, potentially revealing how matter behaves in extreme gravitational fields. Each small shift in the black hole's path, or an unexpected flare, could provide clues about the underlying physics of gravity and high-energy processes. Such observations may help to answer fundamental questions. Are there different kinds of black hole behaviors? How do these cosmic giants influence their surroundings? Investigating XTEJ 1118 plus 480 may ultimately lead to discovering new aspects of our universe that have yet to be understood, revealing the rich and intricate tapestry of cosmic history woven into its anarchic movement.